My name is Indah Anjareski, and I will be your Master of Ceremonies for this special occasions. The Honorable Director of Pontianak State Polytechnic, Dr. Insinyur Haji Widodo PSST MT MCE. The Honorable Vice Director for Academic of Planning Affairs, Bapak Haji Irawan Soeharto STMT. The Honorable Vice Director for Finance and General Affairs, Ibu Linda Suherma, SAMSI. The Honorable Vice Director for Student Affairs and Alumni, Bapak Dede Irwan STMT. The Honorable Head of the Civil Engineering Department, Ibu Insinyur Haja Eti Rabihati MT. The Honorable Keynote Speakers, Dr. Wisena Parceka, Ibu Leli Marini, Profesor Kwok King Kwok, Profesor Ling Jenhua, and Dr. Mahmuda Konburi, and all the esteemed participants of the international conference. Before we proceed, let us begin with a moment of unity and patriotism. Ladies and gentlemen, please rise for the singing of the Indonesian national anthem, Indonesia Raya. Thank you, ladies and gentlemen. Please be seated. Ladies and gentlemen, let us extend a warm welcome to remarks from Ibu Insinyur Haja Eti Rabihati MT, the head of the Civil Engineering Department. The floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Pertama-tama saya ucapkan terima kasih pada Allah Subhanahu wa Ta'ala yang telah memberikan kesempatan kepada jurusan Teknik Sipil dalam rangka melaksanakan kegiatan seminar internasional pada hari ini tanggal 20 Oktober 2025. Tujuan daripada acara ini adalah untuk meningkatkan kemampuan daripada tenaga akademik kami dalam meningkatkan pengetahuan dan wawasan mengikuti International Conference. This event bring together global experts to explore how innovation like AI, BIM, and smart material as transforming infrastruktur. Baiklah, kita mulai saja seminar internasional ini. Tidak begitu banyak. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for your remarks, Ibu Insinyur Haja Eti Rabihati MT. Now we have arrived at the most anticipated moment, the opening address of the Hybrid International Conference on Constructions, Materials and Infrastructure by Dr. Insinyur Haji Widodo PSST MT MCE. We respectfully invite to the stage.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi washabihi ajmain. Amma ba'du. Peace be upon us all. Morning everybody. On behalf of Polytechnic Negeri Pontianak, I am pleased to welcome all distinguished keynote speakers, presenters, participants and invited guests to the hybrid conference on civil construction and material innovation, HICCMI 2025. We are honored to have Dr. Wisena Firseka from Pahayangan Catholic University, Indonesia, and Ibu Leli Marini from Polytechnic Negeri Pontianak, who are attending in person today, as well as from Kwok King Kwok from Swinburne University of Technology Sarawak, Malaysia, Professor Ling Jianhua from University of Technology Sarawak, Malaysia too, and Dr. Mahmudah Kaldori from City of Glasgow College, UK, who are joining us virtually as our keynote speakers. We are truly grateful for their contribution for this conference. This conference serves as a strategic platform to advance knowledge, strengthen collaboration among academy and industry, and explore emerging technologies in civil and construction engineering. In an era of rapid transformation, it is crucial for higher education institutions to promote research and innovation that support resilient infrastructure, digital construction, sustainability, and smart urban development. Polytechnic Negeri Pontianak remains committed to vocational excellences that is research-based, innovation-driven, and aligned with global industry needs. Through HICCMI 2025, we hope to foster the exchange of ideas among experts, encourage international partnership, and inspire practical solutions that can be applied across various sectors. I extend my highest appreciation to the organizing committee, partner institution, keynote speakers, presenters, and all contributors who have made this conference possible. Your participation and expertise will undoubtedly enrich the discussion and outcomes of this event. With great optimism and said Bismillahirrahmanirrahim, I officially open the hybrid conference of civil construction and material innovation HICCMI 2025. May this conference generate valuable insight, meaningful collaboration, impactful innovation for the future of our infrastructure and communities. Thank you, and I wish you productive and inspiring conference. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for your remarks and officially open the international ceremony for this day. As a token of our appreciations, we invite Bapak Dr. Haji Widodo PS to present a souvenir to Bapak Wisena Perseka STMT. Please for Bapak Dr. Haji Widodo and Bapak Wisena Perseka. Thank you for Bapak Dr. Haji Widodo and Bapak Wisena Perseka. Then we also invite Ibu Insinyur Haja Eti Rabihati MT to present a souvenir to Ibu Leli Marini STMA. To Ibu Haja Eti Rabihati and Ibu Leli Marini, please welcome. To seek blessing for the success of today's event, we will now recite a short prayer. We invite Bapak Didik Nur Haris to lead the prayer.
Wabarakatuh. Let us begin this event by praying to Allah Subhanahu wa Ta'ala. May this event be successful and blessed. Please allow me to lead the prayer. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi hamdan yuafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa 'azimi sultanik. Allahumma salli wa sallim wa barik ala nabiyyika wa rasulika Muhammadin sallallahu alaihi wasallam wa ala alihi wa sahbihi wa sallim ajma'in. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana ighfir lana wa liwalidina wa li jami'il muslimina wal muslimat wal mu'minina wal mu'minat al ahya'i minhum wal amwat. Allahumma ja'al jam'ana hadha jam'an marhuma wa tafarruqana min ba'dihi tafarruqan ma'suma. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa ziyadatan fil ilm wa barakatan fil rizq. Allahumma iftah lana abwab al khairi wa abwab al barakati wa abwab al ilmi wa abwab al hikmati وأبواب السلامة وأبواب العافية وأبواب الجنة برحمتك يا أرحم الراحمين. اللهم إنا نسألك موجبات رحمتك وعزائم مغفرتك والغنيمة من كل بر والسلامة من كل إثم والفوز بالجنة والنجاة من النار. ربنا تقبل منا إنك أنت السميع العليم وتب علينا إنك أنت التواب الرحيم. دعواهم فيها سبحانك اللهم وتحيتهم فيها سلام وآخر دعوانا أن الحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته.
Thank you for Bapak Didik M. Nur Haris. To commemorate this important gathering, we will now proceed with a photo session. We kindly invite all keynote speakers, officially and honor guests to come forward for the photo sessions.
Dari situ nanti Bapak bilang next saja. Nanti kita ada poin. Hah? Poin. Oh, poin.
Boleh? Terserah Bapak. Tapi kan good morning, esteemed participants, speaker, and delegates. Welcome to the Hybrid International Conference on Constructions, Material, and Infrastructure. My name is Indah Anjareski, and I'm a lecturer in Civil Engineering Department. It is my great pleasure and honor to serve as you moderator for these sessions. This session will be deal into the critical topic of emerging technologies in civil engineering, transforming infrastructure designs, construction, and sustainability. Before we begin, please allow me to briefly go over the structures and housekeeping rules for these sessions. First, our sessions is scheduled for 5 hours. We will have 5 esteemed speakers. Each speaker will have 1 hour for their presentations and question and answer. The question and answer segment will be held immediately after each presentation. We encourage active participants. Please raise your hand in future on Zoom or in this room, and then when I call up, please state your name and affiliations before asking your questions. Then we kindly request that you mute your mobile devices to ensure maximum focus and respect for our speakers. It is now my distinct pleasure to introduce our first distinguished keynote speaker. Our first speaker is Bapak Wisena Perceka STMT PhD. Bapak Wisena is a structural engineer who work on design, evaluation, and retrofitting projects. He has published numerous influential papers, and his research interests include fiber reinforced concrete, high performance concrete, and the seismic design of reinforced concrete and steel structure. She will be presenting on the topic New Generations on Fiber Reinforced Concrete, an Alternative for Seismic Design of Structures. Please join me in giving a very warm welcome to Bapak Wisena Perceka STMT PhD.
Thank you for introduction. I will stand here. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It's an honor for me to come here. This is the first time I came to Pontianak, and I like the city. The city is very comfortable. So I hope this is not my last time. So in the future I can come here again. Okay, I will start my presentation. My presentation is about new generation of fiber reinforced concrete, an alternative for seismic design of structure. Okay, this is my presentation outline. There are 6 topics. I will try to deliver it very slowly and within the time. Okay, next. Next. Okay, from the beginning, we know evolution of material strength is increasing over time. With thanks to improvement of material technologies, so we can make concrete strength higher, and also the yield strength of longitudinal bars. In order to know the effects of materials strength, higher material strength to structural behavior, so Japan in 1995 until present, they start a new RC project, and after that in 2008 Taiwan followed Japan. They also started a new RC project. Okay, next. In the past, this is the type of reinforcing bar we always use for our project. Especially in Indonesia, we have a grade 40, grade 60, and grade 75. Unfortunately, for seismic design, we are only allowed to use grade 40 and a grade 60. Okay, next a little bit. Okay, next. Okay. So we cannot use the grade 75 because this material, they don't have yield plateau. Yield plateau is when the yield strength occur, so the deformation can still increase, but the strength is constant. So in grade 75, we don't have that. That's why we cannot use it for seismic design. Okay. And thanks to material technology, so we can create higher strength for reinforcing bar, like in Taiwan. Now we can use 685 for longitudinal rebars, and we can use 785 for stirrup, or maybe in Indonesia we call it sangkang, tulangan sangkang, or stirrup reinforcement. We can use SD 785. Okay, next. Yeah, the advantage is we use the high strength material. We can reduce the size of lower story column in high-rise RC building. Yeah, if we can reduce the column size, of course we can increase available floor area and reduce the number of reinforcement, and so we can make construction is easier. And because if we use the older style reinforced concrete, low in strength and large support column required, yeah, in Taiwan, it can be only applied in the construction building up to 27 floors. Yeah, this is the advantages if we use the high strength material. Okay, next. But there is always but. We have also the challenge when we use a high strength concrete. Okay, next. Yeah, if we test the concrete in compression for normal strength and high strength, in general we can see here like high strength we can get very high F prime C or concrete compressive strength. But okay, next. High strength concrete is brittle, less deformation capacity, and increase the brittleness because of high axial loading, especially in column when we use it for low story column. Yeah, we can see from the picture, normal strength concrete after crack, so it failed. But for high strength concrete, it like explosive, so it's very dangerous for seismic region. Okay, next. So in case of RC column, we need more stirrup, like improved stirrup up to 70%, cross ties with 135 degree minimum, or it's better if we use 180 degree, hooks at both ends. Of course, next, we will have a constructability issue. So we have so many reinforcement, it will be very difficult if we want to place our fresh concrete. So we need an alternative material. Okay, next. Okay, next. Yeah, okay, next. Yeah, fiber. Now fiber is popular, and there are many types of fiber, but for structural, especially for seismic design, we use a steel fiber, like a bar and have a hook at both ends. Okay, next. So we can compare here from the graph and also from the picture. Actually, their strength is identical, but their failure behavior is totally different. Like when we don't have fiber, when we use a high strength concrete, yeah, the damage is yeah, we can see it's broken and totally broken. But when we increase the fiber volume fraction from 0.75 until 1.5%, so we found just many crack on a concrete surface. Okay, and for the flexure strength, we also did the flexural test. Okay, and this we did the same setup. Yeah, this test was conducted by my college, Mr. Wu. And from in the right picture, the top picture, we see unreinforced ordinary concrete beam. It failed suddenly, but when we have when we use a fiber, even we don't have reinforcement, so the beam just the crack opening is not as large as ordinary beam. Yeah, and maybe for ordinary beam we can say it is split into two parts. Okay, next. So in fiber reinforced concrete, tension is basically resisted by the fiber because of the large number and small size of the fiber. So the theory of composite appears to offer a proper modeling framework. And this implies defining a new material with properties determined by both the concrete matrix and fiber. And assuming the uniform fiber distribution and orientation, the composite maintains basically isotropic properties. Okay, next. But ordinary fiber reinforced concrete, oh, what happened? Oh, oh. Okay, we have main obstacle. First, workability. We can see we often found a segregation, and the affecting the fiber only affects slightly concrete strength. We can see when we increase the fiber volume fraction, but the peak strength is remain the same. And next, and no multiple cracking and hardening. It's mean when we do the tension test on the conventional fiber reinforced concrete, it only shows the single crack, and after the peak strength, so the strength decreases slowly. So we need the new generation of fiber reinforced concrete. Okay, next. Yeah, new generation of fiber reinforced concrete first was developed in the USA. There are three types. First, engineered cementitious composite, HPFRCC, high performance fiber reinforced cement or cementitious composite, strain hardening fiber reinforced concrete, and all of them were developed in the University of Michigan. And for HPFRCC, the University of Texas at Arlington, they also continue this research. So in Japan, they start DFRCC, ductile fiber reinforced cementitious composite. And next. Okay, and in Taiwan, we start SHFRC, highly flowable strain hardening fiber reinforced concrete. And in Indonesia, started in 2019. So we also try to make highly flowable strain hardening fiber reinforced concrete, high performance fiber reinforced cement and cementitious composite. Both of them are conducted at UNPAR. For engineered cementitious composite, we collaborate with ITB. Okay, next. Now I will show you the characteristic of highly flowable strain hardening fiber reinforced concrete. Okay. Yeah, sometimes we call it still like a strain hardening FRC because it's simple. Yeah, this material has SCC, self-compacting concrete characteristic. It can flow under its own weight without segregation and vibration. That's SCC. Sorry. And HPFRCC. So it has a strain hardening response under tension, accompanied by multiple cracking. So from this idea, from these two characteristics, we try to combine to create highly flowable strain hardening fiber reinforced concrete. Okay, next. Okay, if we see this picture, the top picture is conventional fiber reinforced concrete. So if we see from the point 0 until the point A, so when the crack strength has happened, so it decreases slowly. But in new material, after the crack, the strength can still increase, and it will show more crack. And after the peak strength has reached, so the strength decrease very slowly. Okay, next. But now how to achieve the strain hardening? So it can be achieved by design. So from this formula, this is the how much fiber do we need in our mixed proportion. Okay, next. And the key parameter first is tau, equivalent bond strength at the fiber interface and fiber matrix interface, tensile strength of the matrix, and the coefficient to describe fiber embedded length, fiber orientation, fiber efficiency, fiber group reduction, and fiber include angle, and alpha, the coefficient to count for a bond affected by onset of matrix cracking, fiber orientation, and loading condition. And this formula was adopted by my previous supervisor, Professor Liao, and his research group when he was in the Michigan. Okay, next. Yeah, this is how to get the equivalent bond strength. So we have we do the fiber bond test to get the pull out energy. So the pull out energy, we can calculate it to get the equivalent bond strength. Okay, next. So in highly flowable strain hardening fiber reinforced concrete, the left composition is for F prime C 40 megapascal. It was developed by Professor Liao in 2006 when he was a PhD student in Michigan. So in the right part, so that's we change the composition to get the higher strength, so we can get F prime C around the range from 76 until 85 megapascal. So unlike traditional HPF RCC, we still use coarse aggregate and pozzolanic material. Sustainable construction material can substitute cement up to 40% or greater. Okay, next. And this is the tensile test at University of Michigan. And first they test the slump flow diameter, so they can get 60 centimeter, and they prepare the dog bone specimen to do the tensile test. They have 6 mix, and mix number 1 is control, and what I show you here is mix number 5. And we can see from the picture in the bottom right picture, they have multiple cracking. When concrete, especially normal concrete, if we do the tensile test, of course it will be broken suddenly, and we can only find a single crack in the center. But this material, it doesn't fail with a single crack, so we can find multiple crack. Next. Okay, next. And in 2025, just a couple months ago, when I went back to Taiwan for a postdoc, so we did the tensile test. We refer to our mixed proportion that we proposed in 2021. So first we check the slump flow diameter of SEC without fiber. So the average is 60 centimeter. And after we put the fiber, the average diameter is 50 centimeter. Next. And we make the same specimen, and we can see if the very right picture, that's the middle part of the dog bone specimen. We can see that we have several cracks, and the strain hardening behavior, it happened, it was followed by multiple cracking. So after all the crack appeared on specimen surface, and maybe there is no redistribution, strength redistribution anymore, so the strength will decrease. Okay, next. So the mechanism is the composite will carry increasing loads after the first cracking of the matrix. If the pull-out resistance of the fibers at the first crack is greater than the load at first cracking, at the crack section, the matrix does not resist any tension, and the fibers carry the entire load taken by the composite. With an increasing load on the composite, the fiber will tend to transfer the additional stress to the matrix through the bond stresses. This process of multiple cracking will continue until either fiber failed or the accumulated local debonding will lead to fiber pulled out. Okay, next. Okay, next. Now we can apply fiber to several parts. Of course, it's we don't need to put the fiber for the whole structure. No, yeah, it's very expensive. So we just need to apply it on the several part where we need it to dissipate seismic energy, or maybe in like in the electrical we have a fuse. So this part also fuse for our building when the seismic comes, and that part will let it to have damage, but the damage should be controlled. First is for the base column or maybe base of shear wall, where they are subjected to high axial load and displacement reversals, and also a plastic hinge at the column base, high shear and axial load in region of plastic rotation, and yeah, we high plastic shear and plastic bending deformation for the shear wall, base of structural wall. For joint, external beam column joint. So because in the internal beam column joint, we usually have 4 beams are framing into the joint. So the joint strength sometimes it's higher, but for the external it's different because the joint strength is lower than the interior joint. And the coupling beam. So in Taiwan URC project, we have test 3-part column for confinement, and base column for shear and external beam column joint. And now we just finished test on the shear wall. So maybe I have not prepared the shear wall this time because it was just finished just couple months ago. Okay, next. First, I will show you the shear behavior improvement of RC beam. So starting in 2011 in HICCMI 318, we can use a fiber as minimum reinforcement, but as long as the F prime C not doesn't exceed 40 megapascal, the height of beam is not greater than 60, and external load, ultimate load, is not greater than 7.15 square F prime C BW times D. Okay, next. Yeah, of course, now ACI, they just released the latest one, ACI 318 2025. So in a commentary for ACI 318 2011, so the minimum of fiber is 60 kilo per meter cubic of concrete, or it's equal to 0.75% fiber volume fraction. Why they choose this number? Yeah, because based on the laboratory tests, the shear strength is larger than 0 to 9 square F times C BW times D. Yeah, this is the upper limit of shear strength until ACI 2014, or maybe in our SNE 2847, our concrete standard. the latest one. We still use this for upper limit, but starting ACI 31819 and ACI 318 2025, of course this number is has been changed. Okay, next. And yeah, this is the test was conducted at University of Michigan. Yeah, we can see the top picture is the beam without steel fiber, and the bottom picture is a beam with steel fiber. And if we see the graph, the shear stress of beam with steel fiber, yeah, it's maybe around more than twice strength of RC beam without fiber. Okay, next. And yeah, this is the data where why they select the strength, the minimum strength of 0.29 square F prime C. Yeah, because the data show that the strength always appears upper that limit. Okay, next. Okay, now this is the test was conducted in Taiwan. Yeah, we prepared 3 large scale column, double curvature, with aspect ratio like section height. The column height divided by section height is 3. Okay, next. Yeah, we have 3 specimen. The first specimen S140. It is specimen we didn't have steel fiber. For specimen 140 1.5 and 260 1.5 we have a steel fiber. All the section size is 60 by 60, and all of them were subjected to very high axial load. Okay, next. Next, yeah. We test the specimen on a multi-axial testing system or MATS. So it can apply axial loading capacity up to 60 meganewton. For the lateral loading, it can apply up to 7 meganewton. So this is the setup. And for the structural system, we can see in the right picture, like we have a lateral load and we also have axial loading. And the right picture, if the loading history, that's to simulate the seismic. Okay, next. Yeah, that's the machine will move to south and north. So passing criteria is ultimate drift ratio. Like drift is the ratio between the lateral displacement divided by specimen height. So it's 3%. And so when the strength drop up to 20% from the peak, and we can have a drift 3% or greater, so it's mean the structure has passed. Okay, next. Yes, and yeah, this is the picture. We can see the drift of S140 without steel fiber, only 1.25. Of course, it didn't pass the minimum criteria, but with steel fiber, we can have, we could achieve drift 3.25%. Okay, next. And this is the specimen damage. Like we can see in the left picture, on the second cycle of 1.5% drift, so we see main spalling of concrete cover, and we can see the buckling. But in the right picture, we can achieve drift up to 4%. After at 4%, we stop the test. Okay, next. And the third specimen, we try to increase the transfer reinforcement spacing to 260 to 26 centimeter, but we can still have 3.16 drift ratio. Next. And this is the failure mode. We can see, like, we have so many crack, but the number of concrete spalling is smaller. Okay, next. Now we evaluate the shear strength of the column. First, this is our benchmark specimen. Yeah, we follow the specimen from our college, Professor HICCMI and his former student from Indonesia, Mr. Kurniawan. And this column were made of high strength material with high strength concrete and high strength rebars. And they check the concrete strength. And next. Okay, based on their specimen size, we follow the specimen geometry, but we increase this reinforcement spacing for the left part. When we use fiber volume fraction 0.75%, we use the spacing of stirrup is 50 centimeter, and the right picture we use a 54 because we increase the fiber up to 1.5%, and the fiber is only applied at the middle part. So for the top and bottom foundation, we didn't apply the steel fiber. Okay, next. Yeah, and this is the detail of our specimen. So we put the more longitudinal reinforcing bar because in order to prevent the flexure failure, because our target is shear failure, we want to know the shear strength. Okay, next. Yeah, and this is the first group. There were 4 specimen. And next. Yeah, this is the second group. We also have a 4 specimen, but yeah, we increase the axial load ratio from 0.1 until 0.4. Okay, next. Yeah, we use mats with the same loading history. Okay, next. Yeah, this is the test from the first group. We can see under low axial load, the first 2 picture. Okay, before. Okay, so we can see even we don't have more stirrup, we still can have more crack. So it means the fiber bridging action it worked to redistribute the strength. For the high axial load, even we have like a large crack opening, like a diagonal crack opening, but we still can have a more crack. Okay, next. And yeah, this is when we increase the steel fiber from 0.75 to 1.5%. Yeah, we can the damage failure almost the same, but we can have more crack here, and also of course the strength is higher than the previous one. Okay, next. Okay, now we compare with the first series of new RC column from Professor HICCMI and Mr. Kurniawan, and we can see next. First, next. Yeah, next. Yeah, first group when we have a 0.1% axial load, so the normalized shear crack and ultimate when we have a steel fiber is higher than ordinary new RC. Next, yeah, we can find also for the higher axial load ratio like 0.2, next 0.3 and 0.4. Okay, next. Now this is external beam column joint. So we applied the fiber only to the joint. So the left picture is the traditional specimen. We still have stirrup in the joint. In the right picture, we don't have any stirrup. We only put the steel fiber. Next. Yeah, this is the specimen. We have a 4 specimen. LAMV is a specimen under low axial load, but we have a stirrup. And LAMV SF, we only use steel fiber without stirrup. For the last two specimen is specimen under high axial load. Next. And yeah, this is the definition of the symbol. Next. Yeah, we use the mats and we modified it because the mats we usually use it for column test, but now we use for external beam column joint, and we use the same loading history. Next. And we can see the right picture, the top left picture is the beam with without steel fiber, but we use the stirrup in the joint. So in the right picture we have a steel fiber, but we don't have any stirrup, but the joint is both of them can survive. It means the steel fiber can replace the joint for low axial load. Next. Okay, but for the high axial load, the beam for when we use a stirrup, so the joint is stronger than the beam. Unfortunately, with even with steel fiber under high axial load, we have a joint failed. Next. Yeah, this is the backbone curve from the hysteresis curve for low axial load. Yeah, we can see the strength almost the same, and the ductility of the system with the steel fiber a little bit lower than without steel fiber. Next. This is for axial load. Next. So this is a summarize. So for high axial load without steel fiber, so our failure mode is a beam joint with a drift maximum of the system is 4%. Okay, next. Okay, now we come to our conclusion. So highly flowable strength hardening fiber reinforced concrete provides high ductility to brittle concrete, particularly for high strength concrete. Compared to ordinary high strength concrete, this material presents high toughness, damage tolerant, and excellent shear capacity, while allowing good workability. The experimental results show that addition of fibers can be an effective alternative for transfer reinforcement in high strength RC columns. By using highly flowable strength hardening fiber reinforced concrete, the shear strength can increase up to 4 times compared to that of high strength concrete. Next. Yeah, and by increasing the spacing to half of section depth, d/2 and under 0.43 axial loading level, excellent performance and damage tolerant can be still observed in the column S260 with 1.5 steel fiber, 1.5% steel fiber. It shows the great potential to apply fiber to high strength RC column. And by using this material to external beam column joint, the transfer reinforcement can be eliminated in external beam column joint under low and high axial loading level. A specimen subjected to high axial loading level can still be considered to have qualified performance even though it failed in shear. But however, in practical design, it is highly recommended to provide proper transfer reinforcement. Next. And using highly flowable strength hardening fiber reinforced concrete in a reinforced concrete building made of high strength materials not only provide a great mechanical benefits, but also makes the design and construction easier, allowing for better performance and safety. Okay, next. Yeah, that's all my presentation. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for Bapak Wisena for the highly informative presentations. Now we have open for questions and answers for this room or in Zoom. Please raise your hand.
Assalamualaikum warahmatullahi wabarakatuh. I would like to ask about your presentation, Mr. Wisena. It's really insightful for me. And first, I would like to ask about why you don't apply fiber on the top and down part of the column, while in the joint around column and beam, you apply the fiber. Can you explain more about the reason of that case? Thank you.
So for your first question, if I can repeat the question, is why didn't I apply for the whole specimen, right? Okay, can you go back to the picture, Mr. Operator? Back to, okay, back. Back, okay, next. Okay, next. Back, yeah. Back. Okay, yeah, back. Okay, okay, stop. This one, right? Okay, yeah. Thank you for the question. So, the bottom part and the top part is only to simulate the foundation and the floor, and the middle part is the column. So it's mean when we have like column in lower story building, so this is the top floor and this is the foundation and the middle part is the column. That's why we didn't put the fiber on the foundation. Yeah. And for the second question, can you repeat the question? Second question. Oh, join around column and beam.
Yes.
Still in this specimen, right? Yeah, because we put all the fiber until the face of the foundation. So I think we think it's enough to simulate the effect of the fiber.
To adding fiber on, if we want to next research, is it possible if we try to adding the fiber for the top and down? Or
for if we talk about the in the system, like for example in like a column with column slab connection, like without the beam. So in order to prevent the a brittle behavior for the a punching shear, yeah, we can apply fiber on in the area when we expect the punching shear can happen, so we can put steel fiber there. Okay, thank you.
For the other participants wants to ask a question. Ke Bapak Randi Setiawan.
Mic, please.
I have two questions about your report. Number one, to what extent can VRC replace traditional transfer reinforcement in high-strength RC column and beam column joined without compromising seismic ductile and energy dissipation capacity? And question number two.
Okay, so can you repeat the number one? Sorry.
Number one. Okay. To what extent can HFSH VRC replace traditional transverse reinforcement in high-strength RC columns and beams column joints without compromising seismic ductility and energy dissipation capacity?
Okay, so I will answer the question.
Yes.
It's mean if I can get your question correctly. So you mean how far it can replace the transverse reinforcing bar?
Yes.
Oh,
Reinforced bar.
for the column, for the joint, and for the beam. Yeah. Okay. So I will answer the first question first.
Yes.
So based on our research, the steel fiber cannot replace totally for the transfer reinforcement. It doesn't mean when we use a fiber, so we can eliminate all the reinforcing bar. No, we still need it, but we can prevent the excessive transfer reinforcement. Like we don't need more transfer reinforcements so our construction process is very difficult. So compared to pour more transfer reinforcement, we can put the steel fiber for alternative. That's my answer. Hopefully, you can get your answer from my.
Okay. Thank you.
And-
Question number 2. What are the practical challenges in implementing HFSR VRC for large-scale construction?
Okay.
Particularly regarding workability and quality control and cost efficiency compared to traditional reinforcement concrete.
Okay. So now the challenge is quality control of the fresh concrete. Yeah, because when we want to apply this in the field, in the design project, we when the concrete mixer truck comes, so we put the steel fiber into the mixer, and the mixer we rotate maybe until 10 minutes, and we check the slump flow. But the challenge is when the fresh concrete specification, it doesn't satisfy our requests. Sometimes we ask like a 40 or 50 megapascal, but with some specification. Maybe sometime the truck or maybe the concrete is too dry, or maybe is too wet. That's the challenge. That's why our quality control in the factory, concrete factory, maybe we have to strong control it. And so the challenge also that's the challenge. And the benefit also, we can reduce the time for fabrication of rebar, because when we can reduce the rebar, so the fabrication times we can cut the time. So maybe the whole project times we can save several times, and if we can save times, of course we can save some money.
Oh yeah, but cost capacity ya Pak.
Yes.
Okay. Thank you very much.
Okay, thank you.
Thank you for Bapak Randi Setiawan. For the next questions, Bapak Satrio Utomo.
Okay, represented Mr. Satrio because he is a shy person. So, so there is some question, Mr. Wisena. Is it about whether the surface life of fiber reinforced concrete is the same as that of normal concrete, and how about its durability against weather effects?
Okay, yeah. I think that's a common question I find recently. Many people will ask about durability because we have a steel here, and of course many people worry about the corrosion. Right? Okay. Actually, about the durability, the research is still going on, but in recently, for material level, we at Unpar, we tried to make the cylinder and the dog bone. We tried put it in the water with natrium chloride, maybe 10%, and we let it specimen until 1 year. And after that, when we test the compressive strength and the tensile strength, so the behavior with the with the specimen that are not put in the natrium chloride water is the same. So the performance didn't change. So that's why we believe that for the weather, I think it will not be a problem.
Questions for the participants in Zoom or this room? Okay, if there is no any questions, thank you again for Bapak Wisena for sharing your valuable expertise, for giving other opportunities of the use of new generations of fiber reinforced concrete for earthquake resistant structures. Thank you, Bapak Wisena.
Okay, thank you very much.
Give an applause for Bapak Wisena.
Thank you very much.
Okay, for the second speaker, Professor Dr. Insinyur Ling Jen Hua.
Yes, I'm here.
Okay, we will begin for
Can you hear
the second sessions. Are you ready?
Yes.
Okay? Is it okay for you?
Yeah.
Okay. Before we start for the second sessions, I would like to introduce our second speaker. Dr. Ling Jen Hua is an associate professor in technology Sarawak University. He has published numerous influential papers, and recently he was awarded a grant from the University Research Grant for his project titled Development and Enhancement of Seawater and Sea Sand Concrete Filled Plastic Tubes for Compression Member, where he served as a project leader. Today he will presenting on the topic grounded splice sleeve connections in precast constructions. Please join me in giving a very warm welcome to Associate Professor Dr. Insinyur Ling Jen Hua. For the time is yours.
Okay, thank you very much from the chairman, and I'm very honored to be invited as the speaker for this event. My name is Dr. Lin Chen Hua. I'm from the University of Technology Sarawak, Malaysia. So today I'm going to present a topic on grounded splice sleeve connections in precast constructions. Before we start, let us look at the outline of my presentations today. Basically, it can be separated into three parts, including the fundamental principles, the load response, as well as the current and future research. Without further ado, let us get started. So what is grounded splice sleeve? It is basically a coupler used to connect steel bars. The basic components of a grounded splice sleeve, including sleeve, grout, and the splice bar. The sleeve serves as the container for the grout, whereas the grout serves as the bonding medium to ensure the continuity between the splice bar. When the grout hardens and when we have sufficient anchorage length, it can be able to generate sufficient bond strength. With sufficient bond strength, when the splice bar are inserted inside the sleeve, it prevents it from being slipped out of the sleeve. Therefore, we can ensure a full anchorage loads to be effectively transferred from one bar to another bar. Grouted splice sleeve can be used as the connections for the precast concrete walls. In practice, the sleeves are prefabricated and embedded inside the precast wall during the fabrications. The precast wall members are later being transported to the construction site for installations. During the installations, the extruding bars from the adjacent wall panels are being inserted into the sleeve in order to ensure the continuity. With grout being filled and the grout hardens, that ensure the continuity between the walls panels. This approach will involve very minimal wet casting and therefore it speed up the construction process and also improve the quality control. This approach, however, requires high dimensional precisions, particularly in terms of the length of the bar extruding out from the wall panels, as well as the locations of the rebar and the sleeve needs to be exactly the same in order to ensure smooth insertions of the reinforcement bar into the sleeve without requiring any adjustment on site. Due to these requirements of high precisions, meaning the fabrications of precast wall needs to be done properly to ensure the precise locations during the installations. Other than precast concrete walls, it can also be used as the connections for the columns, for the load-bearing walls to the foundations, for the bridge piers, and even for beam-to-beam connections. Although it is technically feasible, but the applications of grouted splice sleeve in beams are typically relatively uncommon. The main reason is due to the construction difficulty. The installations of the joint for the beams require horizontal installations as well as the horizontal movements of the liftings of the precast beams. This leads to lifting complications and difficulty when you do the installations. Other than that, you need to do grouting in the sleeve. Normally, it is done from the side or underside. This also gives you some challenge because, especially in the case that you do not have a proper platform for workers to stand on to access this at height. Also, there will be risk for the horizontal casting due to improper filling or incomplete filling of the grout. This may compromise the anchorage, the bonding within the sleeve. Other than that, you have also issue with slightly lower flexural strength due to the reason that you need to position the grouted splice sleeve within the members with sufficient covers. With the size of the grouted splice sleeve, typically 2 times to 3 times the size of the rebar, and the rebar need to be aligned towards the central axis of the connectors. That will lead to slightly offset of the reinforcement bar upward, resulting slightly lower bar effective depth. That will give you slightly lower moment resistance as compared to the conventional reinforced concrete members. This figure shows us how the installation is being done. With the sleeve normally prefabricated inside the element, you have reinforcement bar coming out from the another members. You lift the upper panels and you slowly lower it down, ensuring the reinforcement bar are properly inserted into the sleeve. Then you will go with the grouting. Basically, there are 2 methods of grouting. One is by pumping method. Another one is by pouring method. Pumping method will require the grouts to be mixed into the flowable state, whereas the pouring methods, you need to mix into the pourable stage in accordance to the specifications by the manufacturer. Now, how does this pumping method being done? So once you have the reinforcement bar inserted into the sleeve, you will pump into the sleeve through the grout inlet, which is normally located at the bottom side of the sleeve. And then you allow the grout to flow out from the grout outlet. Once it's flow out, you need to monitor. You make sure that it becomes consistent in terms of the flow in order for you to confirm that all the air inside the sleeve is being released. Why is it so? You need to ensure that the entire sleeve here are filled with the grout. This is about the pumping method. Now, in the case that you are doing the pouring methods, the locations of the sleeve, it will be on the bottom side, meaning that on the lower panels. Before the insertions of the reinforcement bar, normally we'll pour in the grout and then make sure it is fully filled. And then with the insertions of the reinforcement bar, and then we wait for the grouts to harden to ensure the continuity. Let us talk about the history of the gouter splice. So initially, gouter splice was proprietary products. There are quite a numbers in the market. Among the common one include the lantern interlock and also NMB splice lead. This type of gouter splice are normally well engineered and they have demonstrated proven performance. Some of these gouter splice connections even come with their own patented grouting material, meaning that we cannot use any grouting material available in the local market, so you have to use theirs. Now, the issue here is these are patented products and normally it will be imported from overseas. When we do not have local productions, that will be quite costly to the constructions. In order to overcome this, researchers come up with an idea, repurposing the standard steel pipe sections. These are materials that can easily be found in most of the construction site and they come with quite a cheap cost. What they did here is they modified them into the locally fabricated sleeve by doing some modifications. They mimic the mechanical behavior of those commercial systems. In terms of the efficiency, they may not fully match the proprietary products. However, it is proven that they are structurally viable, except that they are bigger and bulkier. But the advantage here is it is more economical and anyone can replicate and produce those non-proprietary gouter splice to meet their requirements. Since then, researchers come up with a lot of research using different types of materials. This include the mild steel pipes, high-strength steel, cast iron, aluminum tubes, spiral, square hollow sections, glass fiber reinforced polymers, and etc. These are some of the design from different researchers. There are quite a number. I only extract some of them. What you can see here, the design here, although they come with different types of the design, but they can be simply classified into two major categories. First is about full grouted splice sleeve. The others is the half grouted splice sleeve. Full grouted splice sleeve will have both ends filled with the grouts, both ends grounded, whereas half grouted splice sleeve will have one end grounded, while the other ends being tracted. The tracted ends are normally the ends that embedded inside the prefabricated precast element. is the chemical adhesions, and then the third, it will be frictions. Among these three types of bonding mechanism, the mechanical interlocking plays the most critical roles, contributing the most towards the bonding strength. Therefore, grounded supply sleeve actually focusing on manipulating this in order to maximize its performance. Other than that, we want to ensure high bond strength. It can be achieved through doing the confinement effect offered by the sleeve, which we're going to explain it later, and also using of the high strength grout. So from the literature, we see that the grout strength normally will be at least 60 megapascal and above. And most of them will concentrate around 70 to 80 megapascals. So now we talk about the mechanical interlocking in order to understand the fundamental principle there. So for every reinforcement bar, there are ribs on the reinforcement bar. The purpose of this bar rib here is to have the interlocking between the bars and the concrete, which in the case of grounded splice connections, we are talking about the interlocking between the bar ribs and the grout key. So what you see here, this represents the reinforcement, and this represents the ribs on the reinforcement bar. Once you have grout filling into the sleeve, the grout will follow the shapes of the bar ribs, forming a grout key in contact with the grout, in contact with the reinforcement. Now, as you have reinforcement being pulled, that will generate a resultant force. This resultant force can be divided into the two component shear force, which include the normal stress and also the longitudinal stress. The normal stress here will push the grout keys outward, radially outward, forming the splitting crack. Whereas the longitudinal stress here, it will be, if it is not properly resisted, that will give you the slippage of the reinforcement bar. Now the resistance will be provided by the grout key here, where you will have shear areas here. As long as this shear does not fail, means that the both mechanical interlocking between the rebar and the grouts will still remain intact. So this is how the mechanical interlocking serve as the bonding mechanism. The similar principles apply not only between the rebar and the grout, it's also applied between the sleeve and the grouts. Having this understood, now let us look into the splitting crack and what will be the implications. We have this normal stress pushing the grout key outward, radially outward, that will form the splitting crack. So when it is excessive, it will be as if like the grout blocks is actually moving outward. Having this movement here, it leads to the liftings of the grout key. The lifting of the grout key, theoretically, it will lead to you slightly smaller the shear areas. That will give you smaller shear stress given by the grout key. Now, theoretically, it is like that, but in actual case here, it will lead to the concentrations of the stress, and eventually this area fell and the bar slid out of the sleeve. Now, in order to prevent this affecting the bone strength, we need to control and prevent the movements of the grout radially outwards from the rebar. As a result, when we have the sleeve here, it provides confinements to the movement of the grout. That will help to control the splitting crack. And by controlling the splitting crack, we'll reduce the movement here. And as a result, you can still retain an efficient bond between the bar and the grout. As a result, now once we can control this one, then what we are looking at, it will be the required embedded length. So what you can see here, in most of the studies, the embedded lengths are typically ranging from 6 times to 10 times the diameters of the splice bar. This is relatively shorter as compared to the conventional bar lapping system, where minimum you need 35 times. So you can see a significant reductions in terms of the required anchorage length. And then normally they also deal with the high grout strength, that also in another way improving the bonding between the bar and the grout. As a result, some even they go with a higher grout strength, which can reach 115 megapascal. By doing so, you can actually significantly reduce the bar anchorage length. Now, in order to better understand how it works, first we need to know also the typical failure modes. There are 5 typical failure modes that we observe in the labs. Okay, the first one is the bar fracture failure, where you have reinforcement bar fracture outside the grounded splice, and you have bar bone slip failure. This is due to insufficient bone inside the sleeve, causing the bar to slip out of the sleeve, and grout bone slip failure. This is due to poor interlocking between the grout and the sleeve, causing the grout to move out together with the reinforcement bar under tensions. And then you have sleeve failure. This one is due to poor tensile resistance of the sleeve. Sleeve functions is to reach the continuity between reinforcement, while the stress transferring from one bar to another bar, you need the strength from the sleeve to take the tension. In the case that the tensions is insufficient, in the case that the tensile resistance is insufficient, then you will have sleeve failure. This is another type of failure which normally happens in the half grounded splice sleeve, where you have threaded regions. So it ends up either failure at the threads or tensile failure due to the threaded regions. By knowing these 5 types of failure modes, then more or less we can conclude the performance and the working mechanism in the performance of the grounded splice. You need the bar grout bond, you need the grout sleeve bond, you also need the tensile strength in the sleeve, you also need the tensile strength in the bar, and lastly, your threaded joint here, you also need to monitor. Now, what determines the tensile capacity of the grounded splice sleeve? It will be determined by the weakest of these components. So whichever reach first, that will be the failure mode. Now, because of this that we have learned here, then now we start to make sense various type of design here. You have so many design here, but normally they end up consolidated into several common features. So for example, you need the ribs on the sleeve in order to ensure interlocking between the sleeve and the grout to prevent the grout from slipping out of the sleeve. You need tracks to connect the reinforcement bar with the sleeve. And you also, sometimes some even propose to have end bearing at the reinforcement bar. And this introduce the interlocking with the grout in order to significantly shorten the requirement in terms of the bar anchorage length. Other than that, you can also have the sleeve to be designed in the tapered shape. This one is the physically tapered one. Another one here is they have some wedges here in order to control that tapered area here. And then you have also the sleeve. You need it to take the tensile resistance. Some even introduce both here. Some even introduce both here. The bolt here, sorry, okay. Okay, the bolt here introduce pressure in order to increase the frictions with the rebar, and then some even have the threaded surface. It's meant for interlocking with the grout. These grout holes are provided to facilitate the injections of the grouts into the sleeve. So what you can see here, these are some common features, no matter how the design differ, but normally they will end up to be similar common features here. So this has established the fundamental principles of designing of the grounded splice sleeve. Now, from there, now when come to the design, what we are looking at here is, especially when we want to simulate the tensile strength and the performance through analytical methods. Now, what we are looking at when we want to do the experiment and testing is we want to see the grout and the sleeve bone strength, the grout and the bar bone strength, and the sleeve tensile strength to be higher than the bar tensile strength. Why is it so? Because we want it to, once the reinforcement bar being inserted into the grouted splice sleeve, the bar will not slip out. So the only failure that we prefer, it would be the bar tensile failure. So in terms of the design, you can actually optimize this to be slightly higher than the bar tensile strength. This is as far as what experiment or testing is concerned. Now, in terms of the applications in accordance to the standards has specified that the requirement of the tensile strength needs to be at least 1.25 times the nominal strength of the splice bar, meaning that whatever design strength of the splice bar you increase by 25%, that will be the requirement. Why is it so? It is because we want to ensure the splice bar yield first to give alarms in terms of the tendency of failure before the actual failure. Now, you know that when we use the grouted splice, the best performance, it will be under Asian loads, and it is normally designed to take the tensile loads. Understanding the tensile load alone is not really sufficient, especially when it comes to the actual applications. For example, we use it in the wall panels. Depending on the wall frame system and the locations of the connections, the loads may vary significantly. They may be tensile loads, they may be shear load, and they may be flexural load, depending on the locations. Now, what we have observed here is most of the literature, the studies, they focus on the tensile test. Not many go with the actual testing under the shear and flexural load. Only recently, they look into the real applications, including for the seismic studies. So this studies was one of the study that we conducted in our lab to simulate their wider spectrum in terms of the behavior. So what we did here is we studied two different types of the connections. The details is here, and studying the effects of the bar and anchorage length, as well as the sleeve diameters, varying by the sleeve diameters. And we did the tensile test, we did the shear load test, with the shear loads applied along the joint between the two wall panels. And we did also the flexural load test with the loads located at 2.1 meter from the joint of the upper and the lower panels. From there, we need to, in order to test this, we need to come up with the loading frame in order to ensure the stability, as well as to impose load onto the specimens. So in order to optimize it, we try to make it identical and compatible to be able to simulate the shear loads and also flexural loads there. These are our preparations of the material in the lab. We do the samples for the tensile test, shear test samples, and the flexural load test samples. And then we do the installations and then testing in the lab. These are the data acquisition system. So typical data acquisition system include the LVDTs measuring the displacement, load cell measuring the loads, strain gauge installed on the reinforcement bar to measure the strength, data logger to record the readings, computers used to monitor the real-time load displacement response. And then we need loading system also. We have the hydraulic cylinders, we have manual hydraulic pump, and also we have loading frame to apply loads onto the specimens. These are the tensile test behavior. Basically, various type of failure modes are obtained. So the common one, it will be grout slip failure, bar bone slip failure, and also bar fracture failure. So, and then the result come out to be something like this. And then in the case that when you have adequate bone here, normally you will have the ductile failure. But if you compare with the actual tensile behavior of the rebar, it is slightly different, where you will have a smoother transitions at the yielding point here due to the development of the microcrack inside the bonding with the grout. And when you have inadequate bone strength here, normally it will end up to be quite a brittle failure, which it fails suddenly. Now, in terms of the parametric response, because we studied the diameter of the sleeve and also the bar embedded length. So if we increase the sleeve diameter, actually the confinement level, it will be slightly lower, and that will give you slightly lower tensile strength. Now, if we have longer bar anchorage length, then you will have more risks to undergo the interlocking with the ground, and as a result, it gives you higher bone strength. In terms of what we can conclude here is we want the sleeve to have small diameter, and we want the reinforcement bar to be longer, being embedded inside the sleeve. However, in the practical considerations, there is a limit in terms of the sleeve diameter. It cannot be too small. Why is it so? Because we need to allocate tolerance for the installations on site. Okay, so the requirement normally the tolerance, it will be at least 25 or at least 1 to 2 times the bar diameter size, so that you can have a better smoother insertion process. As for the bar embedded length, of course, structurally we like it to be as long as possible. However, the longer bar it is, that means you will have longer extruding bar out of the precast members. That can lead to the handling issues, and that can make it to be quite impractical to manage, especially when you come to the transportations and installations. So in that case, we have to strike a balance between the structural requirements and also the practical considerations. Now, how about under the shear loads? We know that actually grounded splice perform well under tensile load, but it is not necessarily perform well under the shear loads. The main reason here is due to these bar tower actions. What you can see here, you will test it in the lab, and we can get a very high ultimate load, but you will have problem with a very low surface load, which is about only 1/3 of the ultimate strength. Now, why is this service load important? It is because when we design for the applications, then we cannot have the loading exceeding this service load. Otherwise, there will be deformations that is irreversible, and that can lead to the concern in the long-term durability of the connections that may affect the integrity of the overall structures. Now, this bar tower action here can be divided into 2 parts, where we have bar bending actions and bar kinking actions. So what are those? We can have a look on how it responds. Now, when you apply the shear load here, it leads to the concentrations of the stress here. Later, you further increase the load, it will lead to a hinge happening at the joint here. So this is where the bar bending actions happen. Once this hinge reaches to a certain stage, this part here will be undergo tensions. So because of this happen the bar kinking actions. So what we'll have here is during the bar bending action here, the hinge occur, the strength will reduce slightly, and then you have very significant plastic deformations. Once the bar bending actions consolidated, now the reinforcement bar will be under the tensile load, then this develop the bar kinking actions. As a result here, it become more or less linear. But the issue now here is you have very high shear loads, but very low service load. You have very significant amount of the strength being wasted. So personally, I do not recommend to have the grounded splice alone to take the shear loads. Now, in order to overcome this, this is the one that I'm referring. Actually, we even hack into the concrete and to observe what's actually happening inside there. Then you see the bending deformations of the bar after the shear loads. So in order to overcome this, we recommend that you need some shear keys at the joint here to have those shear keys to carry the shear loads, whereas you leave the grounded splice leaf here as a mechanism to take the tensile loads. With the shear key taking the shear loads, and that will still make the grounded splice be applicable to take under the shear conditions. Next, we talk about the flexural loads. The flexural load here similar to the tensile loads, except that there are combinations of the tensile loads and the shear loads. In this case, if the tensile load is more dominant, then the failure will be more closer to the tensile failure. So when you have sufficient bond, then normally you get the more ductile failure. Now, if you do not have sufficient bond slip failure, then you will have a sudden failure. Now, this shows us how the internal stress respond under different types of load. To make it simple, tensile loads, you will have a more uniform internal stress here, and normally it gives you the best performance. So you will require the shortest bar anchorage length. However, under shear loads, if without the presence of the shear key, actually the performance is very poor due to the bar tower actions. And because of the shear loads here is applied is in the perpendicular directions of the reinforcement bar, and this will happen at the very weak directions of the connections. So the performance will be relatively poor. It leads to the reconcentrations of the stress, and where certain areas are actually not really effectively bonded with the concrete. So that will actually the performance relatively poor. Now, as for the flexural loads, it's actually the combinations of the tensile and the shear loads. And that shear loads will also lead to the reconcentrations of the stress, and certain areas the stress appears to be relatively low, meaning that you're expecting a non-uniform internal stress, and you are expecting a longer anchorage length in overall as compared to the tensile test. Now let us look at current research climates, and also we are talking about the future development, which this is the third part of our discussion here. So I did the bibliometric analysis through the Scopus database, and then come up with 400 something documents related to the grounded splice. What you can see here is the output in terms of the publications, and also the citation is actually increasing. However, it peaks at the 2023. After that, it start reducing. So, but we don't know what's the reason why there is a sudden reduction here. So I try to figure out why is it so. My personal understanding here is actually we still need time to observe whether the field is actually reaching the maturity. But my personal perception here is more or less there already. Why is it so? Because if you see various types of the design, you can see some design can actually achieve with only 3.5 times the bar diameter. Imagine this is actually very short. So it's already as short as it is possibly can get. And we also see some design actually managed to go with the 150 megapascal. So now the ground is also already as strong as it can possibly go. And what you can see here is, although we have new design being developed, but it will end up to be similar strengthening techniques. Means that the one that common features that we observe, it contribute quite limited new techniques in order to strengthen the grounded splice. So my personal perception here is it may be reaching to the maturity, but I'm not sure whether it is due to this one, the reductions in 2024. 2025 is not representative because I only get the data up to June only. So we still need time to observe whether it is still continue dropping or what. But my personal first impression here is it may be reaching the maturity. Okay, so also next we are looking into some researchers. So there are quite a number of clusters, and if you have been familiar with the bibliometric analysis, you study the other field, normally you will see a larger cluster. But I find this one is quite unique because the clusters are normally relatively small, and normally within their size of maximum 8 persons in the clusters. So why is it so? I try to find the explanation for that. I believe is because developing grounded splice leaf are more towards the developing products which can be patented and have this commercial value. So normally the size of the member may be slightly smaller than if we go for the fundamental research. But we find it quite interesting. There are different types of clusters. You have the emerging clusters. So these clusters are actually new to the field here. And then we have evolving clusters. You will have old researcher, you have new researcher, and you see the transfer of the knowledge among the researchers. And you have stagnant clusters, means that they have no new contribution, new outputs. It's more or less stagnant there. And we also have domain cluster. So these are the early players. So they are highly cited because they are the early player, but now they are no longer active in the field. So we can see different types of the clusters here. So in terms of the research teams, we have the applications, we have also the fundamental research focusing on the connectors and others. And in terms of the top publishers, I guess at the moment is China dominant the publications. They have a lot of institutions and sponsorship over the relevant studies. So in terms of the outputs by country, I guess China has dominated the relevant research. Now let us talk about the emerging trends and the future research directions. So my personal observation here is actually we have the research focus shifting along the years. So it's actually shifting from the initial looking into the feasible design, trying to optimizing the connections, trying to minimizing the anchorage length, try to increasing the ground strength and so on and so forth in order to make it as optimized as possible towards now, because have a wider acceptance in the industry. They have applied those in the industry. And then they realize that there are a lot of practical defect, construction defect, and practical challenges. So if you observe, there are a lot of recent publications, they are focusing more towards simulating this kind of defect. For example, okay, what are the practical challenges? Practical challenges include the manufacturing defects in the prefabrication elements, in inconsistent contractor practices, and also the use of incompatible grounding equipments. Common issue here, they include the insufficient ground height, poor compactness, rebar misalignment, inadequate anchorage length, and also delay in grouting. So this figure here shows a typical examples of the common defects that we can encounter. You pump the grout from the inlet and then you ensure it flow out. So once it's flow out, you know that more or less it is fully filled. You're expecting this will happen, but sometimes there are backflow due to the gravity and spilling of the grout. So eventually what is actually being embedded inside the grout is not as what you expect it to be, and this is going to compromise the bond strength of the grout supply slip. So once they are aware that, they have a lot of research looking into those aspects. You have 1, 2, 3, I just highlight a few. But what you can see here is interestingly, their methodology they use is slightly different, but actually they are simulating the similar cases. So for example, like they purposely make it insufficient anchorage length and to observe what will be the implications. Okay. Also, there are another type of studies studying different construction defect, such as this one represent no defect, this one represents some defect here, regional defect, and this one represent the more uniform defect along the reinforcement bar or defects happening at the midspan. And also this one to simulate the defect when it is improper filling of the grout when you do the horizontal casting. So this kind of defect here, how do they simulate that? They actually embed certain other materials such as the foam, such as the soil, such as the plasticine, or they just simply leave it as a void in order to simulate how the grouter splice connector will perform under those defects. Now, by having this incorporated inside the grouter splice leaf, although it may not reflect the actual construction situations, but it's actually simulating how a similar conditions when there are defects in the construction site. Other than that, they also study what if there are corrosions, so how they deal with those. And some even go slightly further, extending, because once you've done the casting, once you've done the grouting, actually everything remain inside of the precast members. You don't know whether it is already properly filled or not. So some even develop some mechanism to monitor method to detect whether there are void defects inside the grouter splice leaf. And some even study the elevated temperature. So what you can see here is the current research direction seems to be more industrial related, and also the scope become broader and go into the other aspect than optimizing the connections. So with that, let me conclude my presentations. So first, grouter splice leaf are efficient connectors that enhance the construction speed and the quality of the precast system. Their performance is very much dependent on proper design, installations, and quality control. Now, early study here, we see the focus actually in the reducing the anchorage length to make it more compact, to make it lightweight, and without compromising the strength. But now we have growing recognitions in the construction challenges, which prompt to the shift of the research focus and design priority. So personally, I believe eventually it may reach to a balanced approach, where at the same time you acknowledge that both structural efficiency is important. At the same time, you have to also consider the real world construction challenges. With that, I conclude my presentations. Thank you very much.
Thank you for Professor Ling Jianhua for your presentations. We now open for questions and discussion dedicated to Professor Ling Jianhua for the participants. Please raise your hand if you want to ask a questions. Okay, from the participants.
Okay, thank you for having me. Your presentation is very insightful for me. So I have two questions. First, how can potential hidden defects inside the slips be detected without damaging the installed connection? And the second one, can the growth supply slip system meet the demands of sustainable precast construction in terms of material use, recyclability, and energy efficiencies? Thank you.
Okay, so your question here is how do we detect the uh, how do we detect if there is a defect? Normally, previously, actually, we don't know. Okay, so previously, what we did here is we ensure the grouts are filling from let me show you the slides. Grouts are being injected, okay, being pumped inside here. We ensure there is sufficient pressure here, and then to push the grout out from here, and then we monitor until the clouds is actually steadily flowing out here without any indications that there's still releasing of the air void, then we stop there. So in order to ensure that, first we have to ensure really good flowability property of the grout. So before we pump the grout, we have to do this flowability test before that. However, in the actual applications that the contractor may not follow the entire procedures here. So, as far as I am aware of, so far I encountered one papers here is using this mechanical vibration wave. So to have the signal going in and going out to detect whether it is fully filled or not. So I hope that answers your first questions. And then the second question is on the sustainable applications. Um, I guess if we really need to justify for the sustainable part here is it minimize the material wastage by reducing the amount of the wet casting. So actually precast concrete actually if it is being done properly in the factory, so that one actually we can minimize the wastage of the material. And then when we do the installations, there will be very minimal wet castings. So the wet casting will involve the dry pack that joining the members and also involve the grouting. So this actually involve very minimum amount of the reinforcement bar, and it doesn't require any forwards. So if we really need to justify on the sustainable part, probably it will be the use of the material. I guess it can be minimized, and especially the temporary forwards. That one, if we save that, actually we can save a lot of the wastage of the materials.
Okay, thank you, Mr.
Ibu Wiwi for the questions. And for the next questions,
Yes, do you have any questions? I will be very happy to answer.
Okay, for the participants, is there any questions? Okay, Bapak Daslin Tobing.
Excuse me, sir.
Yeah.
I am Georgios Giri. I'm question. If this connection fails, how will should fail impact the overall integrity of the precast structural system? Thus, they still cause redundancy to prevent collapse.
Okay, let me try to understand your question. What if the connection fail? How would the wall frame system would fail, right?
Will impact the overall integrity of the process structural system. Thus, it still causes redundancy to prevent collapse.
Maybe I
Let me try
can.
to understand. Yeah.
For the questions, if these connections fail, how would such failure impact the overall integrity of the precast structural system? Does it still possess redundancy to prevent collapse?
Yes, it depends on how we design the wall frame system. Okay, so normally when we design for the precast wall frame system, uh, we need to consider in the case that any of the members here uh, are unable to perform as it is. So in that case, in the case that any one of the members fail, so that may lead to the progressive failure. So in the typical precast concrete structure design, they have this tie system to help to prevent those. Let's say now one of the members fail does not perform as it was intended it to be, and then you will have those tie system here to prevent, to minimize the impacts of the progressive failure. But as far as the Goddess price connections, if it is fail means that rectifications will have to be done over that lah. So, but Goddess price system itself also in the case of failure, I guess you have to be rely on the integrity of the structures. So in that case, it will be still go back to the fundamental design of the precast structures on the tie system, at least to hold the structures so that remediations can be done. Okay.
Okay, is it
Have I
clear?
answered your questions?
Gary, is it clear?
Yes, yes.
Thank you for the answer for Professor Ling Jianhua. And then for the other questions, Bapak Daslin.
Okay. Hello, Prof. My name is Daslin. I have one question for you. How does the failure mechanism of growth space sleeve connection affect the global behavior of precast structures? Is the detail of, or does it still profit surface apa nih?
Come again?
It's still
Sorry, yeah,
flows.
sorry.
Maybe I can help to make it clear. How does the failure
Sure.
mechanism of grouted splice sleeve connections affect the global behavior of precast structures? Is it brittle or does it still provide sufficient ductility?
So first, let's say because you're looking into what if it fails, right? So normally, first, when we want to design the router splice connections, we have to make sure that it will not fail in the brittle manner. So that's why we have the standards required at least 1.25 times. So when it reaches 1.25 times, normally if you test it in the lab, you will see the ductile failure. Now, from the research point of view, normally to me, this may not be good enough. Okay, so my personal point of view, if when I come to my own research, I'm looking into this as the requirements. We need the bar tensile strength to fail. Other than we don't want the other types of failures to occur. We only want the bar tensile strength to fail. Means that the failure, we want to divert the possibility of failures to the bar itself alone instead of the connections. Why? Because we don't want to have more complicated in terms of the design. How do we simulate this kind of failure? So if the bar is self-fail, means that there is actually the issue that you do not provide sufficient reinforcement bar to join the wall frame system. So in that case, we eliminate the possibility of the failure. When we control this, we eliminate the possibility of failures at the grouter splice itself. Now, if the reinforcement bar actually fail, then you're going to expect that there will be ductile failure. So this ductile failure here, once it's occurred, so I guess the first implications, it will be redistributions of the stress. So redistributions of the stress between the global structures until when eventually this cannot last, meaning that the other part also cannot withstand that, then it comes to the failure. Then this will have to transfer the loads later to the pie system in order to prevent the progressive failure in that case. So whether it is going to be a ductile, yes, because from the start, we want the failures to fail in the ductile. So we don't go for the insufficient anchorage length that will give you the brittle failures. So this is how we control the modes of the failure.
Okay, Pak Daslin, is it okay?
Okay, thank you, Prof.
Okay, thank you.
Professor, there is a questions in Zoom. Maybe I can read for you.
Sure.
I would like to ask how effective is the connection system compared to conventional cast-in-place monolithic concrete?
Connection system, the first thing here is we want to compare the precast concrete structures and the conventional cast-in-place monolithic structures. They are by nature, they are very significantly different in terms of their working principles. So for example, like if we are designing the conventional RC structures, we are looking into the design at the service state. So it means that this is the typical that we design in our reinforced concrete design structures. We design for the ultimate loads, moment and shear, then we check the serviceability and so on and so forth. Now, when it comes to the design for the precast concrete structures, we need to design at 2 stages, or sometimes it needs to go with the 3 stages. So the first stage is we design at the ultimate state, means that the similar like the one that we design for the RC structures. And then we have to also consider, okay, during the construction stage, meaning that because you have to install the members one by one during the constructions. So when you install the member one by one, it does not come everything overnight, everything in the actual structure here. It is actually progressively being installed one by one. So you need to simulate how the loops is going to apply during the constructions. That may lead to certain issue like the rotational and torsional issues, which may not happen at the service stage, but during the construction stage, because you only install one by one, so you have one side loaded at the other side, not yet having the panels onto those. So these are the things that you might need to simulate. And also, normally there will be like the second casting. Sometimes you will have scripting over the and those, and maybe some second casting there. That one you might need to also simulate that, so it may end up to be second stage and the third stage. Now, in terms of the connection system, basically, if you want to compare the effectiveness, of course, the rigidity sides, it will not be comparable to the conventional RC structures. Okay, so whatever connection it is, no matter how you're going to make it, like you want it to be quite fixed, but normally it will not be the perfect fix. So what we can say here is normally, typically the failure, it will be at the connections. So it's either failing in the sleeve itself or failing near the sleeve. So if you really want to compare on that sense, meaning that the strength, it might not be comparable. Now, how do we overcome that? Normally, it's either, let's say, if you have a wall frame system, still okay. But if you are talking about skeleton frame system, you might need some proper bracings, and also might need to complement with some load-bearing wall in order to complement the lateral loads and so on and so forth. So in order to complement those weaknesses. And in additional, like the one that we mentioned, you might need some tie systems also to prevent what if the connections does not perform well. So if really compare, they are totally two different types of system. So if you want to compare in terms of the rigidity, of course, RC structures is more rigid, and there may be construction joints between the panels. And this we need to overcome that with other type of system. Okay, I hope this answers your questions.
Okay, thank you,
Thank you.
Professor. Is there any questions? No? Is it enough? Okay, if there is no any questions, I would like to say thank you for Professor Dr. Insinyur Ling Jianhua for your presentations, and then for our discussions for these sessions. Thank you very much, Professor Ling Jianhua. We can give applause to him.
Thank you very much. It's my pleasure to share this topic.
Okay, we move to the next sessions. Is for our third keynote speaker, Mr. Professor Kwok King Kwok. Are you ready? Good morning, Professor. Good morning, Professor. We cannot hear you. We cannot hear you, Professor. We can see your slides, but we can hear your voice.
Hello, can you hear my voice now?
Yes, we can hear your
Okay.
voice. Is it okay we start now?
Yeah, I would like to share my slides.
Okay, I will open first.
Yeah, can you hear me now?
Yeah.
Okay. Sorry for the disruption. Welcome for this hybrid international conference of constructions, materials, and infrastructures. So today, what am I going to go through will be a part of the works that we have done throughout the years. So we have used the drone. We have used the drone to monitor the construction and the planning for the Kuching Centralized wastewater treatment systems. Whether okay. So the contents that we are going to go through today are including the introductions, some reviews of the drone, the methodology for us to do the monitoring and inspection of this project, Kuching Centralized Wastewater Management Systems, then results that we obtain, and some discussion on it, And then we also have some conclusions, and also the last one will be the future of drones. How do we apply? So normally when we go to site to do the inspections, so we will face some challenges. One of the challenges will be when we inspect at a high level of ground. So what we need to do is we have to put on scaffolding. Sometimes we need to put on the aerial lifts, and then to install the scaffolding to install the aerial lift, we need the specialized people to install it so that when we go up, it will not collapse. So for the installation of this scaffolding and the aerial lift, it needs a time. It needs some money to be spent on that. We need to engage the special people to put it on. So it will cost us some extra time. It will cost us some extra money. Okay, for the installation when we do the inspection at the higher level ground, and then if we climb it out during the inspections, so there is the risk for us to fall down. So the risk is high when we do the inspection. So and at the same times, when there is some defects on site, okay, during the inspection, especially at the high-rise building or sky raptors, what will happen is if you have some defects which is far away from the place that we can reach. So what will happen is the defects is maybe as the days goes on, it will be getting bigger and bigger. Then when we notice it, okay, when we notice that, we need to pay extra cost to do the repairs. And then if this happen, it will cause the project delays, and then it may cause destructive potential safety failures to the whole building in futures. But all this problem, we can solve it if we have drone. So we have drone, then we can fly the drone through the construction sites, especially at the higher elevated ground. Then we don't need to put on the scaffolding. We don't need to put on the aerial lift. From there, we can save the money. Okay, we can save the time for putting out all these infrastructures, and we don't need to climb. So the risk of us to fall down from the construction sites will be very, very low. And then if there is some defects, then we can fly the drone slowly across the building, and then it can capture all the images as a footage. Then we come back, then we slowly go through it, and we know where are the defects where are the defects have happened. And with this, it will save the time cost. It will reduce the risk of failure for the accidents from the happens, and then it will reduce the rate of failure or defects, because all the defects have been captured through the footages, and then when we come back, then we slowly look into it. Okay, and not only that, the drone have some other capabilities. If we install some systems, some sensors, okay, for example, with the LiDAR scanning systems, then it's able to fly through it. It is able to capture the spot levels of the ground. And then not only that, it is able to measure the distance from one point to another point by using these LiDAR scanning system sensors or LiDAR sensors. And at the same time, we also can install some thermal sensors on the LiDAR. Some of the places is overheated and the temperature is not correct, especially where there is electrical hotspots, that it can be detected, and this will avoid the fire from happening. Okay, therefore, that's why in this case we try to employ the drones for us to do the inspections. For this particular project, the project that we have employed in our study is a Kuching centralized wastewater treatment systems. So these are the list of annual objectives that we are going to use for using this drone. Okay, the first one is to study the feasibility of the drone application for visual inspection and also for the project monitoring. Then we also try to come up with the calculations. What are the time, what are the costs that we can save if we go to the site if we use the drone to do the inspection compared to our traditional inspections. And then thereafter, at the end of the day, we try to come up with method statements. We try to come up with the procedures, okay, for the drone for visual inspections and monitoring and supervisions. Okay, the scope of work that we are going to go through, okay, we try to compare the time and the cost that we can save by using the drone compared to our human supervisions. And then we try to utilize the drone, okay, to monitor and inspect the sites during the pre-construction stage, during the construction stage, and also once the project has been completed, okay. So some history of the drones, okay. Drone actually started in year 1949, okay. The initial idea of the drone was come from unnamed hot air balloons, okay. It's from air balloons, and then it was developed by Austrian Empire assaulted Venice, okay. And then thereafter, they found out that the hot air balloon is not that advanced. That's why, and professors, Charles, together with his friend Jess and Louis Brackett, so they developed the first quadrupeds. Quadrupeds meaning to say that the helicopters with 4 propellers, and it was developed in year 1907. Okay, and in 1916s, the British, they have developed the pilotless aircraft, the aircraft without a pilot, and then the name of this pilot is the Ruston Proto Aerial Target, and then it was developed in World War I, and then in 1937, the British had developed the Queen Bee, and only the first time they call it as drone. And in 1960s, they renamed the drone as an unmanned aerial system, the short form is UAS, and also named as Red Wagon. Basically, is to do the patrolling or to safeguard the areas, and all these are for military purpose. And now the name of the drone, when they change it into an unnamed aerial vehicle, the short form of it is a UAV, okay. And apart from military purposes, then we can use it in agriculture, in constructions, and some other purposes. Of course, nowadays you can see that the most popular usage of the drone basically is the war, during the war, especially within the war of Iran, and also the Israel, and also the war in the Ukraine, and also the Russia. Okay, they use a lot of drone at the time. Okay, just to show you some of the pictures just to share with you some of the pictures of the, what do you call that, the unnamed air balloon. The picture on the left is the unnamed air balloons that was developed in 1949. So it's just a balloon, okay? And it was developed by Austrian Empire Venice, and they used it when Austrian Empire tried to attack the Venice back to year 1949. And the picture on the right basically is a quadruped, the helicopters with 4 propellers, we call it quadrupeds, and this one was developed by Professor Charles back in year 1907. Nowadays, we use the drone in various areas. Apart from military purposes or for attacking one country to another country, so we also use in the public sectors, we also use in the commercial areas, okay, commercial sectors. So military purpose, I think all of us know that in the recent war in between the few countries, they use a lot of drones, okay, it is able to deliver the bombs, okay. Then it is can be used to attack the area through the long-range surveillance drones, okay, meaning to say that this type of drones, it can fly for 5 hours, okay, the distance that it can fly maybe 50 kilometers, then it can carry the bombs and then attack the opponents. And then in military, they also use the drone to do the patrolling to safeguard the country. If there is some people that are attacking, then they use the drone to fly in the sky to safeguard the country, to avoid to inform the person in charge when there is someone want to attack their empire or their countries. Okay, and apart from military use, drone have been used for public sector usage. Okay, so the first one is search and rescue. Let's say, for example, it's people that lost in the jungle. Okay, so we can use the drone to search and rescue the people. If the boat was suddenly sink in the middle of the sea, okay, then we can use the drone to search the victims. And the weather forecast, okay, it can be attached with certain sensors, then it is able to forecast the papers, able to forecast the weathers, especially is able to send the thickness of the clouds. And then we can use the drone to do the mapping. There are various types of mapping that we can do. The first one is the 3D mapping, okay, meaning to say that we fly the drone through it, then it's able to collect all the footages, and then we can create a film for it. I think we can see it normally in our YouTube. And another thing is, if we attach with the sensors, then it is able to capture all the spot level on the ground. And from the spot level of the ground, then we are going to transform into a survey data. Okay. Then it can be used in the commercial as well. Okay, so nowadays more and more countries they use the drone to do the inspections and monitoring during the construction process, because we don't need to be there all the time. We just fly the drone and then we can see the progress of the site. And then every day, one day we do four to five times. Then we can get the data. We can capture the footage immediately. Then we know the progress clearly, and it can be shared with some other people. We also can use the drone in agriculture purpose, so we can use it to spray the pesticide. You can use the drone to do some of it. We can use the drone to do some other things, and then we can use the drone to put on the fertilizers and so on, for plantings and so on. And in certain cases, so we want to capture the buildings, the beautiful architecture of the building, then we flow the drones and fly the drones, and then it can be event photography, or it can be event photography just to promote the particular buildings. Okay. So in Malaysia, we have the rules and regulations to fly the drones, and the government agency to control the drones, the flying of the drones in Malaysia, we call it Civil Aviation in Authority of Malaysia. The short form of it is CAAM. Okay, so these are the list of the regulation for us to fly the drones. The first one will be the drone cannot operate in the class A, B, and C airspace. So this is a big technical. So these are the conditions of the classification of A, B, C, and G. So I'm not going to go into it because it's too technicals. And then the second one is no drones can be flown within the 5 kilometers of any airport. Meaning to say that from the distance of the airport, we cannot fly the drones at least within the radius of 5 kilometers. So if it is outside 5 kilometers, then we can fly the drones, because we scared that the flying drones will affect the routine of our commercial flight. And then in commercial drone operations, we need to get the permissions from the Director General of CAAM. Okay, and if the drone, the weight is more than 20 kilograms, some of the drones, it is a more advanced one, the weight may be 3 to 4 kilograms. Okay, if it is more than 20 kilograms, we need to get the permission from Director General of CAAM. And then if we want to fly the drone to capture the footage and so on, okay, then we need to be registered with CAAM through online service, through online. Okay. And then another condition, regulation will be we cannot fly the drone within the aerodrome traffic zone and also beyond the 400 feet, meaning to say that we cannot fly the drone higher than the 400 feet above the ground. And then some of the places we cannot fly the drone as well. So in Malaysia, the places that we cannot fly the drones are including Putrajaya, Kuala Lumpur City Centre, KLCC area, Parliament, Istana Negara, for all the police stations, all the prisons, all the government offices, and all the military bases. We cannot fly the drones. So if we fly the drones within this area, so the immediate impact will be, we will be charged under section 1486, okay, of the Penal Code, okay. So just to share with you some of the common drones that is available in the market. Okay, the most common one nowadays in Malaysia is from Tajang Innovation. This logo of Tajang, the short form of DJI. So some of the drones that we normally use, you can buy from the shops, including the DJI Phantom, okay, DJI Spark, DJI Mavic A. Okay, these are some of the drones that we can get it from the shops. Then I think throughout Sarawak or throughout Malaysia, they have the outlet nowadays, okay, in the shopping malls. Another one which is quite common drones, common brand that we normally use is Unique International. This is the logo for Unique, and one of the models that they are selling over here is Unique E30Z 30X optical zoom drone. Okay. So there are various types of drone that we use it in construction industry. The first one will be the multi-rotor drones. So meaning to say multi-rotor, by the time we look at the name, then you can see that you have a few propellers. So over here, this multi-rotor drones has 4 propellers, and one of the most common type of multi-rotor drones that we can get easily over here will be DJI Mavic Pro. And second type of a drone that we use in the industry is fixed wing drones. We need to say that the wings are fixed up by the time you fly. And the name of this drone is Sandfly EBX. Another one is a bit look like helicopters. This type of drone we call it single rotor drones. Okay, the name of it we call it VAPO P55 UAE helicopters. And another type of drone that we use in the construction industry is fixed wing hybrid VTOL. VTOL is a new technology where it can take off and land vertically. Okay, so one of the name of the drone that we are using is Falcon Vertigo. Okay, just to share with you some of the benefits of using the drone. Okay, we use the drone to do the survey. Okay, we connect it with the sensors. So we've used the drone to do the surveys. The immediate benefits is the speed for us to do the survey is 60 times faster compared to the manual surveying on site. Okay, so the drone surveys, it can survey the area for 120 acres per hour. Okay. Compared to the traditional method, we need to say that we use the topograph and then measure the spot level on site. Okay, maybe the most we can go is maybe 5 acres per hour. But if you use drone, it can survey 120 acres per hour. The time reduction, the time can be reduced for 96% compared to the traditional survey method. Okay, so it is able to, it just needs a few hours, then it can capture all the required data. And the accuracy, okay, due to the advancement of the technology nowadays, the accuracy has been reduced to centimeters level accuracy. So if it is in centimeters level accuracy, so it is meaning to say that it's quite accurate. So with the accurate data, then we can know, we can calculate the volume of the soil that we need to fill, volume of the soil that we need to cut off, okay, by the time we do the cut and fill processes. So in construction industry, okay, so we also use the drone to do the inspection. So basically, we assume that it is able to reduce the time for about 50%, okay. So it just needs half of the time.
Bisa minta tolong nggak? Tadi kan ke depan kan?
Can you hear me, right? Can you hear me?
Yes,
right?
Sorry
Okay.
for the interrupting.
Okay. We just need about 50% of the time to do the same works if we do the traditional survey, okay, to do traditional inspections. And the cost over here is not the cost for buying the equipment. The cost for the one that we want to compare is the cost for us to do the inspection. Let's say, for example, if we just fly the drones, okay, the cost that it involves maybe the price, the cost for us to purchase the drone itself, okay, and also the salary to pay for the engineer for flying the drones. Because if we have the drones, the engineer have multi-function. Apart from flying the drone, they need to do some other works. They need to prepare the report as well. But if we engage a special technician, okay, to fly to do the manual inspections, so we have to pay them the monthly salary. And at the end of this presentation, I will show you how much money that we can save. It is quite ridiculous, but basically we assume that we can save about 75% of the construction of the inspection cost if we fly the drone compared to the traditional methods. Okay, so if we fly the drone, we don't need to climb very high, especially the buildings in nowadays. It is maybe a few hundreds meters from the grounds. Okay, we fall down, there's no life for us. Okay, so we will eliminate the high risk. Okay, we just fly the drone, we can get the data that we want, then finish. That's all. Okay, we don't need to risk ourselves to climb high. If we fall down, then okay, this is the end of the day. And then there's some, due to the advancement of the technology, so we also do some constructions in the very toxic environment, and sometimes the structure may be unstable. Okay, then we still need to climb. So if we fly the drones, then we no need to get in touch with the unstable structures. Okay, we no need to go. We don't need to go into a confined space, such as the small tunnels, to check the progress of the works. Okay, we can just fly the drone and get the pictures, and that's it. And then a toxic environment, okay, sometimes maybe some of the construction site, it may release some toxic gases, then it is very dangerous for us to go into it, and then for us to capture to monitor the progress of the work. So in order to overcome all these problems, just fly through the drone, and then it is, even though the environment is toxic, the gas is toxic, and then if the space is confined, the drone can do all the works, okay? And we don't need to climb, we don't need to go into the confined space, we no need to expose to the hazardous or toxic gases, then it will reduce the rate of accidents. Okay. Another benefits that I would like to share with you is that it will boost the communications for 65%. Meaning to say that once you capture the data, okay, especially the footages, you can share the data with the person in charge, with the stakeholders. And then with this, it will boost the communications for 65%. Whatever you want to know on site, look at the footage that have been recorded. Then everybody can understand, instead of taking the feature from site at different angle, at difficult positions. Okay, the data that we can capture, we can use it to produce the reports. Okay, if you want to produce a report in a soft copy, then you can attach the footages. You want to prepare the report in a hard copy, then you can capture the photos. Okay, from the footages that have been recorded. And the best thing is the data that we have recorded. Okay, the footages we obtain, we can integrate with some others engineering software. One of them is building information modeling, and I think if IBM nowadays is getting more and more popular, and we can use it for free, download it for free through Autodesk, because it's part under Autodesk now. Then we can download it for free and use it for free. We can integrate it with the CAD softwares and then some other project management systems. Okay, cost saving, we have mentioned quite a few times already. Okay, then we have, apart from paying the cost for paying the technicians to do the inspections, okay, so by buying the drones, we also reduce the cost for buying the expensive equipment or renting the expensive equipment such as the cranes, lift, and the scarf folding systems. And of course, we reduce the cost for paying the laborers to capture the pictures, especially the site supervisor or technicians. And then it will minimize the project delays. So how are we going to interpret that? It will be, okay, if you fly the drone 4 to 5 times a day, okay, every 2 hours you fly the drone, then you know what is the progress, okay? Then if the progress is very slow, then you can start questioning the people on site. Why is it very slow? What happened? What happened? And then with this method, okay, then there will be a way, then they will monitor all the time, and then they cannot try to delay the works. In other words, okay, they'll try to snacking on site, or in other words, is try to delay the works. Okay, and with this, it is able to reduce cut the inspection cost by 75%. Okay. And another good things of using the drone is the data that we capture is high resolution, high accuracy. Then we can do a very precise modeling. We can do the very accurate calculations, especially in terms of cutting and fill. Okay, when you construct the roads, you involve a lot of cut and fill. When you open the new sites, then you involve some of the areas involve cut and fill as well. If the data that we capture by the drone is accurate enough, then we are able to assume, or we are able to calculate the total amount of soil, then it be cut off, the total amount of soil, then it fill in accurately. And then at the same time, we use the drone, then we can have a continuous tracking on site. Okay, so crowd smart construction management, we, apart from monitor the building, okay, so we also use the drone in some other part of the other phases of the constructions. One is, the first one would be site survey, okay. Before the construction starts, then we want to survey the site, we want to get the spot label, then we fly the drone, then we will capture the data that we need, okay. Then the second thing is we can have safeguard the safety management. The one we mentioned just now is we shoot the drone, then we will not to expose ourselves to the dangers, to climb up the elevated area high, and then go into the confined space, exposed with the toxic. But if we fly the drone all the time, you can see the movement of the crane, the people, and then the lorry, and so on. If you can see there's some danger happen at the site to the footstep that you capture, then you can immediately tell the people, oh, this thing is coming, and then try to stop it to avoid the accident from happening. Okay, and of course we can use the drone for progress monitoring, as we mentioned, fly it through 4 to 5 times a day. Then you can see what is the progress that we are able to achieve within a day. Okay, and then the good things is all are being recorded. If someone is asking what is happening from this time to this time, all are being recorded in the footages and they cannot run away. Okay, this is the superiority of using the drones. We use the drone at the 3 different stages of the construction. One is the pre-construction, before the construction start. Okay, so this is important for us to identify the potential hazards that are dangerous or difficult to assess, the risky situations, okay? And then with the drone technology, then we don't need to go to site by ourselves, then we just fly the drone through it, and this is made the job of the site inspection become safer, faster, and cost-effective, okay? And then it is able to provide precise measurements. Okay, during the construction stage, so where we can use the drone, it will be during the foundation stage. Then we can use the drone to monitor the workers, okay, to do the digging and laying the foundations, okay. When they put up the scaffolding, we can monitor the progress of the work for the staff on site, workers on site, to putting up the scaffoldings, okay. So it will put extra level of security surveillance. We need to say that it will monitor the safety of the site throughout the time. If an accident will happen, then we can inform it quickly, okay. And it's able to move it's able to track all the moving elements on site, okay, including the people, materials, supplies, and equipments, okay. So if we can monitor the construction sites closely, then we can come out with the scheduling, okay, in detail, in more accurate, and then we can determine identify what are the maintenance dates, and then what is the amount of the materials that have been reached on site, okay, by the footages that we have recorded, okay. And then the data that we captures, okay, we can create the 3D map model, just like flying drones to an area, then it is able to transform into the video and share with the stakeholders. Okay, in more advanced level, okay, maybe we can use the drone to carry the tools, okay, to transport the tool, equipment, and materials. And in more advanced level, we can use the drone to do the spraying, the paint, okay, external walls, okay. And then if we want to paint, it's very dangerous. It is 100 feet away, 100 meters away from the grounds, okay. Then one of the ways to reduce the risk, maybe we can use spray and using the drones. And then what I can remember is in China, they even use the drone to put out the fire, okay, okay. And if we want to install the waterproofing equipment at the very difficult areas or very dangerous area or very risky area, then we can use the drone to put out the waterproofing, especially especially on the skyscrapers, okay. And sometimes we can capture the whole building and capture all the images, and then we can do some promotion of buildings by using the drones, by using the videos that capture using the drone. Okay, and once the project has been completed, okay, it's not at the end of the day. We need to monitor the structural maintenance from time to time. We need to maintain the structures from time to time. Okay, so if the building is too high, such as skyscrapers, towers, and bridges, one of the ways for us to check the sustainability of the structures, maybe we can use to fly the drone through it and obtain the relevant informations or relevant videos, and then to ensure that the structures that were built is safe and sustainable. Okay, and then if we found there are some failures, okay, there's some defects, then the owners of the building or relevant authority, they need to come up with the planning schedules to rectify it or to repair it. Okay, and sometimes drone is able to detect the leakages, okay, and even identify what are the areas that the leakages can happen. Okay, and then this will help us to maintain the to do the maintenance in the more appropriate and more wisely. Okay, so methodology, what we are going to do is if we want to monitor the site using the drone, these are the stages that involve. First, you need to plan. You have to define the inspection scope, identify the critical areas. You got to fly. Then after that, you need to do the map flighting path and ensure regulatory compliance before the deployment. Then after that, you deploy the drone to sites, and then after that, you monitor the sites with the videos that have been captured, and then after you do the processing. Either you are going to do the 3D mapping modules or so on, okay, and then share with the stakeholders. So we have done 2 case studies, okay. Sorry, we have done 2 case studies, okay. The first case study is we try to compare the time, the cost that it can be reduced, okay, by flying the drone, okay. So these are the steps involved, okay. The first one is we do the pre-flight checklist. So we need to charge the drone, okay, and then we need to plan and confirm the weather forecast for the time flight, okay. Then we need to register the drone, and then we need to verify the manual controls, okay, operate properly after takeoff. Then after that, we have to checklist our data collections. So the step 2 will be the plan and design the inspection routes, or the plan and design the inspection routes. There were the routes for the human traditional inspection and the routes for the drone, and then notify the site managers and the engineers. Then we need to have our stopwatch to record the time, and then we try to have a human manual runs to update the latest progress. And start the step 3, we try the drone, and then we compare with the traditional inspection methods. Then we try to record the time. And then step number 4 is analyze the data, and then try to compare the data, the cost, and all the time that have been captured, okay, that have been obtained by through manual inspection, and also the inspection using the drone, okay. And thereafter we analyze the data and then prepare a summary and document for each experiment. So the site that we have identified is a centralized wastewater treatment systems. So there are 4 areas that we are going to involve in order to check the time and the cost. Okay, the first one is secondary purifier tanks, highlighted in the pink color, and then dewatering building, highlighted in the yellow color, activated sludge water, highlighted in the green color, and then the influent pumping stations, okay, highlighted in the purple color. These are the 4 sites that we are going to inspect on site, okay, under case study number 1. Case study number 2, okay, we try to fly the drones, okay, do the inspection or monitoring during the pre-construction stage, during the construction stage, and also the post-construction stage. Okay, the steps are involved are quite straightforward. The first one will be the free flight checklist. Okay, then we need to charge it first, and then we need to collect the data manually. Okay, to get the information on site manually. Okay, and then thereafter that we need to inform and seek the approval from the project engineer, and then thereafter that we try to collect the data. Okay, before we collect the data, we need to do the calibration, and then we need to deploy the drone to the areas that we want to capture the data, and then we have to repeat the steps. Okay, for the pre-construction stage, during construction stage, and then also the post-construction experiments. Okay, and then step number 3, we try to analyze the data. Okay, we try to evaluate in terms of the details, in terms of the time, the cost, and the safety concerns. Okay, thereafter, what we need to do is these are the results that we obtain. The first one is case study number 1. Okay, these are the data that we managed to capture on site manually. Okay, so what do we do is, let me show you. Okay, this from station, from the main station to the station number 1, it takes about 360 seconds. Okay, for station 1 to station number 2, it takes about 450 seconds. So, okay, for station number 2 to number 3, okay, then it takes about 300 seconds. 3 to 4, it will take about 120 seconds. 4 to 5, it takes about 600 seconds, and thereafter that we come back to the main station. It takes about 660 seconds. Altogether, it's equal to 720 seconds. Okay. If we fly the drones, okay, the time that we capture is much more lesser. From the main station to the station number 1, it only takes about 60 seconds. So station number 1 to number 2, maybe we'll delay it a bit because we try to monitor the progress. It takes about 300 seconds. Then from number 3 to number 4, and number 2 to number 3, okay, it takes about 60 seconds. 4 to 5, it takes about 60 seconds. 5 to 6, it takes about 120 seconds, and then we fly back to the main station, 180 station. So it takes about 780 seconds only. Okay. So if we fly the drone, so these are the comparison. If we fly the drone, okay, with the comparison, if we fly the drone with the traditional, what do you call that? Traditional inspection method. The picture on the left is the picture that we capture using the traditional inspection method. So you can see from the left top pictures, okay, you can get the picture at certain angle only, because so we cannot fly. We also cannot fly. We only can take the picture at the best position that we can find on site. Okay, so this is the best position that we can find on site, and this is the picture that we managed to catch or to capture on site. But if we fly the drone, then we can fly the drone right in front of the structures, then we can get the very detailed pictures. And then the picture on the bottom left, okay, what you can see is we cannot climb up. Okay, we need to stand on the ground to take the pictures. So these are the best pictures that we managed to capture. But if you use the drone, so okay, you can place the drone light in front of the place that you want to capture the pictures, and this is the result that you are able to get. And then if you share the pictures, of course, every stakeholders will be very clear, will be what is happening on site. Okay, this is the construction activity starts better. The picture on the left, top left. Okay, you want to before the concreting. Okay, before the concreting, what you do is you try to check the steel bar. And this is the best position that we can capture the steel bar. But if you fly the drone, okay, you can really see into the tying in between the steel bar, and then you can really go into the size of the steel bar, and then you are able to check what is the actual size, whether the site is safer for concreting or not. So the picture on the bottom left is a construction of the cobble. And then this is the best position that we can capture the pictures. And then on the left and the right is if we use the drone. Okay, this is the best picture that we managed to capture. Okay, as we compare the time and the cost, okay, the traditional methods, the first inspection, it takes about 42 minutes. Drone technology, it just need to take about 12 minutes. So walking distance, because if we walk, we cannot go straight from one place to another place. We have to walk through the path. Okay, the total distance that we walk through, in this case study, 2.55 kilometers. If we fly the drone, the total distance that we have fly through is only 0.94 kilometer. Okay, time efficiency, one day we can save 30 minutes 1 month, we can save about 13 hours. Assume that 1 month we work for 26 days, and 1 day with 12 months, then we can be able to save for 160 hours. So the cost efficiency, okay, nowadays the minimum salary in Malaysia is 1,007. For 1 year, we can 12 months, we can save about 20,400 ringgit. Okay, if the project life is 6 years, okay, the total time being saved will be 36 hours and cost saving. Okay, just the cost for paying the technicians, okay, to do the inspection or cloud over to do the inspection, we can save about 122,400. Okay, and it will not reach the what they call the technician to climb up and down. Okay, and the rate of the accidents that are happening on site will be reduced significantly if you use the drone. And then at the same time, the engineer have to do more work. Okay, then you have to fly the drone, you have to prepare a report, you have to do the inspection from time to time. Not every day go to site, but not go to the site, but when there is something happen, then you have to go to site and then solve it. Okay, case study number 2, we try to use the drone for these at the 3 stages of construction. This is the pre-construction, during construction, and post-construction. Okay, so if we use the drone, then you can fly at the best positions, and then you try to capture the pictures on site. Okay, as accurate, as detailed as possible. And these are the pictures that we managed to capture. Okay, this one was done quite some time ago, back to year 2001. Okay, you can see from here on 4th of August, okay, there's not many machinery on site, and then 11th August, more machinery coming to site, 18th, okay, more machinery coming on site, and then the 25th of August, then we start to do the excavation works. This is the construction of the shaft, okay, it's a huge manhole, and then the 28th, okay, and then you can see more works are going on, and then they try to deepen the construction of the shaft. So if you use the drone to fly through it, you can do the comparison during the construction, okay, before and during the construction stage. So what you can see over here is the road are more the same. The only difference is, okay, before construction, there is no shaft on the road, okay? The traffic is still moving smoothly. But once you construct the shaft, okay, you can see this is the shaft that you are having on site. Okay, this is the shaft that you have. This is another shaft that you have on site. Then you can see that the construction of shaft, okay, during the construction, but then it is not disrupting the traffic as well. Okay, if the traffic is if your construction has disrupted the traffic, then after you fly through the drone, you need to do the verification on site. Okay, this is the benefit of using the drone, and you can do the comparisons before and during the construction stage, and at the same time, if there are some, if disrupt the traffic, then you need to come up with an immediate action. Okay, so this is the construction of the secondary clarifier at different stage, and then the first picture you can see is doing the foundation. Then they put up the geotextile for one single secondary clarifier, and then the next one will be the geotextile of the 3 secondary clarifier, and so on. And then these pictures are captured from the plan, so you can see in detail what are the actual progress that are happening on site. But you can, if you have the site view, and there are some differences on site. Okay, so this is the comparison in between the conventional inspection compared to the drone inspection. So if you inspect the site manually, so you only can take the picture at certain angle, and then you have to join the pictures all together, and then tell the people what is happening on site. Okay, but if you fly the drone to the site, what will happen is you can see the overall pictures and tell the people what is happening on site. Okay, and you can fly the drone at different angle. Okay, and it become your footages, and then it will become a record, and this will become your proof to inform the stakeholders. Okay, if there are some defects, okay, let's say over here there are some defects. Okay, if you use the phone if you use the traditional inspection, you can zoom out whatever you can due to the capacity of your phone. Okay, then it cannot get close to the defects area. But if you fly the drone, then you can see this is the defect that have been identified, and then you zoom in, then you can see whether does the steel bar have been exposed or not. If the steel bar is exposed, then you have to come up with the rectification and the repair immediately. Okay. Then after that, if you have the drone, then you have the overall pictures. Then the good things is you can have overall pictures of the site that you are supervising. And then after that, when you do the report, then you can put in some additional pictures to show that a different angle, different point of the construction site, what is happening. Okay, this the most important thing is if you fly the drone, okay, you can get the overall pictures and the details. You can use the data that you get capture on site to insert into the picture to be part of your report. Okay, then with this, we are able to we have successfully used the drone to inspect the sites during the pre-construction stage, during the construction stage, and after the constructions, especially for the maintenance stage, during the maintenance stage. Conclusions, okay, drone basically is able to capture the site, okay, capture all the relevant informations, okay, accurately, especially with the footage that we managed to capture, and then it is able to improve the construction safety, and then it will reduce the risk of accidents from happening, okay, and then with the data that we capture on sites, then we can share with the top management. Okay, then the top management can monitor the site. Okay, from the report area. Okay, from the office, they can see what is happening on site, which is 100 miles away. And then with the data that we capture, we can document our documentation. We can submit the report accurately. Okay, and if there are some investor involved in this project, especially the one who give the money, then we can use the data that captures, okay, to report to the investor. Either it's a private investor or the government agencies. Future of the drones, okay. Future of the drones is hopefully in futures, okay. What will happen is the drone can integrate the deep learning, the AI deep learning and machine learning algorithm can be integrated into the drones, and then it is able to detect the what they call anomalies, we need to say the defects, and then it is able to classify the defects severity and determine how much time, how the subsequent works need to be done in order to repair the defects, okay? Then we can use the drone to do the indoor inspections, especially with the confined space, tunnels and so on, where it is very dangerous for human being to go into it, okay? And then in future, hopefully we can use the drone, okay, as a forklift or cranes to lift the construction material from one point to another point, okay? I think, thank you very much. Yeah, thank you very much. And then if you have some questions, maybe we can contact me using this email. And currently I'm working with Swinburne Sarawak. That's all, thank you very much.
Okay, thank you, Professor. Give it applause to Professor.
Yeah, thank you very much.
Okay, it's time for us for questions and discussions. Is there any questions? Maybe from the Zoom first. May I read for you, Professor?
Say again.
There is questions from Zoom. May I read for you?
Okay. Yeah, sure.
Okay. The question is about how effective is the use of drones in area with step contour, while elevation data is really needed to determine building elevations.
What? Can you repeat your questions?
How effective is the use of drones in areas with step contours, while elevation data is really needed to determine building elevations?
Oh, okay. Actually, drone have been used wisely for doing the survey. Okay, so doing the survey, so the accuracy of the of the data that we managed to capture, if we use the drone, okay, due to the advancement of technology, is in the centimeter level. So, so the accuracy would, meaning to say that the data that we capture on site would be in the differences would be within 1 centimeters. So in this case, the data that we captures would be can consider very accurate in this case. And then normally if we fly through the drone, okay, normally we are not going to use it to measure the height of the building, but most of the time we are using it to capture the spot level on sites, okay? Then from there we can use it to capture, to determine the volume of the soil that we need to cut off, the volume of the soil that we need to fill in on site. Yeah, so the accuracy is up to centimeters level, meaning to say that it will be plus and minus within 1 centimeter or plus and minus 10 mm. The accuracy is higher, in other words.
Okay, thank you, Professor, for your explanations. Maybe for next questions. Okay, Bapak Arif.
Okay, thank you. Your presentation, Mr. Kwok King Kwok. My name is Ikhwan Arif Purnama. Okay, and one question. Is there the specific drone and specification required for the monitoring and construction planning? What's the specific drone, Mr. King Kwok? Thank you.
Okay. Just to share with you, the drone that we've used on site in this works is DJI Mavic Pro. It's a multi-rotor drone. The cost is not so expensive. It's about 3,000 to 4,000 ringgit Malaysia. Okay. Then if we want to do the inspection, okay, the distance that it can fly, using this drone is about 5 kilometers, not 50. The army one maybe 50 kilometers. The distance that it can fly using this drone is about 5 kilometers. Okay. Then the battery is about half an hour. Okay. Then after that we need to be charged. So in this case, this type of this drone is good enough, okay, for us to do the inspection for site, and then it is able to transmit the data to our to the screen, and then after that we can download it, and then we can obtain the footages. And this the DJI Mavic Pro is good enough for us to do this inspection on site. Okay. Of course, as the times goes on, there are more advanced technology coming out, and then it is more expensive. But let's say, for example, if you attach to the LiDAR sensor, okay, the cost may go up to 100,000. Okay, depends on what the accuracy that you like to have. Okay, and then of course when the cost of the drone is 100,000, but when you capture the data from the one area, then you can charge more lah. And for your information, the charge for 100 acres in Kuching, okay, previously I don't know what is the latest rate. Previously, it could cost about 300 to 400,000 ringgit Malaysia.
Okay.
Yeah.
How long a minute to DJI Mavic Pro, Mr. King Kwok, flying? How long fly?
How long do I play this DJI Mavic Pro? Is it? Yeah, it's about we only start this in year 2021, so now it's about 3 to 4 years only lah. Yeah.
The batteries, how long? 20 minutes for?
Oh, the battery is 30 minutes. Battery is 30 minutes only. But of course, the one that we are having is 30 minutes. But now the latest one, I think the technology had been improved, then I have not obtained the latest technology, latest version of Mavic Pro that have been released by DJI, but of course it is higher, just like our smartphone. And then you can see that now the battery life, it is much more longer compared to the 3 to 4 years back. And then you see the EV car, the battery now can go for a longer range. The latest one, I have not obtained the latest information, but the one that we are using, 30 minutes.
Okay,
Yeah.
thank you,
Yeah,
Mr.
thank you.
Kwok Won Ki.
Okay, for next question.
Thank you for your time. My name is Rifki Atiaullah. Mr. Professor, I want to asking about the question. I see the drone is really more effective, especially with time, but I want to ask is, can drone technology completely replace the traditional method? And if it's not, under what condition is it still necessary to use traditional methods? Thank you.
Okay. So, drone, for the routine one, for routine works, okay, where it is repetitive, okay, I think it is not that necessary for the engineer to work on site, to go to site to work on one place to another place every day, okay. But we can replace our energy, working energy or inspection energy on site with the drone. But when it comes to the situation where the drone cannot solve the problem, let's say for example, okay, let's say for example, one of the example is if there are some failure, okay, on site, then there are some discrepancies in between the drawing on site with the drawing and the actual construction on site, okay, then in this case, drone cannot do anything. The most drone can do will be capture the picture, then capture the picture, and then based on the picture they capture, engineers need to go to the site and bring the drawing together with him and rectify what is happening, okay, to rectify the discrepancy rectify the discrepancy with what is happening on site with the drawings, okay. Then as the time goes on, in other words, what I'd like to say is the repetitive work, the works that we need to do it every day, okay, then it can be replaced by the drone. And only when there are things that we rectify and judgment by the engineers, okay, then only then when engineers need to go to site and rectify the things. Okay, am I answering your questions?
Thank you, sir.
Yeah, thank you.
Okay, any other questions? There is a questions also from Zoom about there are numerous advantages to using drones, especially in the surveying process. However, during the process, has there ever been a case where signal interference occurred during operations, making it difficult for the drone to reach certain areas?
Can you repeat your questions?
Has there ever been a case where signal interference occurred during the operations, make it difficult for the drone to reach certain areas?
Yeah. One of the examples that I would like to share with you is the tunnel. Because when we construct the Kuching centralized wastewater treatment systems, okay, the tunnel was constructed underneath the ground, okay, using the drilling tunnel boring machine that drill the tunnels underneath the ground. So if we fly for a distance, maybe for more than 500 meters, okay, so there is the risk that we might lost the signal from the drone to the receiver. Okay, so when this happens, there is the possibility that the drone will not come back. So this is one of the risks that this is one of the difficulties that we'd like to share with you. And then another difficulties that we'd like to share with you is if you fly the drones. For example, the drone that we are using is Mavic Pro. Okay, then when sometimes if we fly too far away, when the wind blow, okay, there is the possibility where the drone will not come back to our to us. Okay, then we might lose the drone. So these are the risks that we need to bear in mind. But if we just use the drone to fly within the boundary of 1 to 2 kilometers, then it should be not a very critical problem for us to employ the drone to do the monitoring works. Yeah, and also the inspection works.
Okay, thank you.
Yeah, thank you.
The other questions?
Pak Rijal, is there any question, Pak Rijal?
Okay, maybe the last questions from Ibu Iren.
Okay, doctor. My name is Irene. I have one question. Do you find any challenging in integrating drone collected data with BIM or GIS platform for real-time planning and monitoring of wastewater treatment facilities?
Can you say again?
Do you find any challenging in integrating drone collected data with BIM or GIS platform for real-time planning and monitoring of wastewater treatment facilities?
With BIM, is it building information modeling, is it?
Yeah, BIM, building
Okay.
image.
This one, frankly speaking, we have not integrated with BIM yet. And I know BIM is getting more and more popular nowadays, and we are working on that as well. But we have not integrated. We have not integrated the Spanish speaking. We have not integrated the drone data, okay, 3D mapping with BIM yet. Spanish speaking, yeah. But we have not explored in that aspect yet at the moment. Yeah, French speaking. But if there is a possibility, it can be done. Yeah, we have not done that yet.
Okay, how about GIS platform?
BIS platform?
Yes.
Oh, I think I'm not very sure what is that at the moment.
Oh, wait.
Yeah, I'm not very sure what is that. But for the monitoring and then for the inspection on site, we found there is no problem at the moment. Not much problem that we face. We use the drone to do the monitoring and inspection on site. Okay, at the moment.
Okay. Thank you, doctor.
Thank you.
Okay. Thank you for Professor. Professor Dr. Kwok King Kwok for your presentations and then for your discussions. This is maybe we will take a break first before we continue for our next sessions. Maybe we can give an applause for Professor Dr. Kwok King Kwok for the presentation.
Yeah,
thank you for your time.
Thank you very much for your having me today. And then this is my contact. If you have any things, then we can contact through the email. Yeah, this is my contact. Thank you very much.
Thank you, Professor.
Thank you.
We will continue again in 1 p.m. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Today we will start our next sessions. Please allow me to introduce our next speaker. Our first speaker is Ibu Leli Marini STMM. Ibu Leli is one of lecturer in civil engineering of Pontianak State Polytechnic. The scope of her instructional expertise lies in the area of soil mechanics, foundations engineering, concrete structures, geopolymer concrete, and machine learning. Today she will be presenting on the topic vibrations in use energy harvesting from pavement mat with high performance geopolymer concrete. Before Ibu Leli Marini start the presentations, we will watch the video from Ibu Leli Marini. Okay.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Okay, before I start the presentation today, the last video is given by the team is like I want to transfer what the concept actually, what the presentation, the subject I want to give today. So that is maybe it could be from how the precast block concrete become the renewable energy. So that is the short video, and that show to us how the work for the principle, the precast concrete technology can harvest energy for something like IoT device or something like street light, for example, like that. Okay, for just how to alternative become renewable energy. Okay. Before that, okay, first of all, I would like to express my deepest gratitude to Polytechnic Negeri Pontianak to trust and opportunity for me given here, standing here today is truly an honor to me to be able sharing a small part of my research journey. I also wish to extend appreciation for team committee HICCMI that already arranging this seminar. I think this is not only for the platform we sharing the knowledge each other, but this is how the amazing opportunity we can collaborate, we can grow together in how to give impact for the civil structure actually. Okay, and then I'm fully aware that there are many distinguished researchers in here, many lecturers in here, many experts in here. There are like very experienced and knowledgeable than I am. That's why I feel deeply humble to genuine and also genuine thankful for this opportunity, this precise chance to present here. I truly hope that our discussion today will give us valuable feedback to civil engineering. Okay, we start. For the slide 1, there is no back before. Okay, this is the title that I work. Not only me actually, I have a team collaborate for the 3 different fields, not only civil engineering, but chemical engineering also and electrical engineering. So this is our goal, how to collaboration, not only civil, we work together, we can complete everything in one goal. So this is the title, Vibration Energy Harvesting in High Performance Geopolymer Mortar. This is a concept, like the video we show together. A proof of concept how piezoelectric system integration to concrete block and precast in our road. This is I will to introduce. Marini is me, and then Manan is my supervisor. He is a professor in civil engineering. Ahmad Kwebeng Hong also, Abdullah also, there is for civil. And then Abed, he is from Emirat Arab. And then Guna Sekaran from India. And then Yunis Baswik, he is electrical engineering supervisor also. So they all gathering together, working in this innovation technology. Okay, please next. Okay, now we go to the need for sustainable pavement solution. We all know that our street have a lot of stress. You can imagine the transportation infrastructure now demand to high structure because they are heavy vehicle, crowded traffic, and then the structure is not enough strong, like not enough strong. You see that the figure, the first is early edge cracking. The cracking is start from the early in the Portland cement concrete or like traditional concrete. And then plastic deformation. It is happen to because in aggressive environment, something like that, and then under heavy vehicle for loading. And then the worst of the problem is fatigue failure. It cannot be maintenance if this happen in our road. So what should we do? We have trying this one, thinking of how to find the alternative that can changing this problem. At first we see environmental imperative, conventional Portland cement. We know all this. For Portland cement, for fabrication manufacturing process, there is contribute 5 until 8% for global emission carbon dioxide. There is until make our climate change. So many researchers have to find the alternative to change the cement. So, and then after that, energy opportunity, traffic-induced vibration are currently dissipated. Actually, the traffic is very crowded. I see in Pontianak, especially. Why the energy from the piezoelectric system, we can harvest energy from the vibration. So many crowded the traffic, it could be we harvest the energy from the mechanical energy, we come to electrical energy. This is we want to talk about it to here. And then performance limitation. OPC concrete suffer from cracking, fatigue, and deformation under heavy cyclic loading. So that's why OPC cannot be we use anymore for the sustainable. So we find the alternative material that could be facing the problem of sustainable. Okay, please next. Now, the solution of the problem is we use HPGM, high performance geopolymer mortar. Why we choose this? Because the first is low carbon alternative. For the producing this product, there is mostly using the raw materials from the waste material, something like industrial waste, something like byproduct, something like that. Okay, then, so there is can be make a low carbon alternative. And then the second, we have tests for chemicals, for strength, compressive strength and flexural strength and etc. For the mechanical performance, there is make it HPGM is superior durability. And then the last is the important thing. If we use the raw material or waste material, we can manage how the waste material utilize for our product, utilize for the future. So we can work together, collaborate for the manufacturing. That is how to manage the waste material in useful. Okay, next please. Okay, let's explore the raw material we use for HPGM. For A, that is fly ash. You see this one is very super fine particle. It looks like 50 micrometer. So very, very fine. And then this is a high aluminosilicate. So for geopolymer concrete or geopolymer mortar, there is need high aluminosilicate. And fly ash is the prioritas one. And then the B, image of B, there is slag. Slag, this is after the grind, yeah. For the first is like a stone, many size of the stone, and then this is after grind. So we have the particle is super fine also. We need super fine particle for HPGM because this is mortar, not using coarse aggregate. So the point thing is how make denser matrix for the mortar. Okay. Slag is from steel, manufacturing steel. And then C is silica fume. Silica fume is obtained from silicon or ferrosilicon alloy industry. In manufacturing process, they can give the waste like this silica fume. And then C is sand. And we use not sand like usual we use for concrete normal. We use sand for geopolymer is fine sand. The size is less than 300 micrometer, so very fine. So that's why the result is very denser. Okay, and then E, this is anhydrous sodium silicate. This is a chemical substance, and this is quite expensive. So maybe this is the weakness of our product is very expensive because we use some chemical from the industrial, not until now not giving the alternative for other chemical. It's like substitute this chemical. So one of our member from the Polytechnic also, he is a lecturer from architect, Pak Heri Prabowo. He is make something new chemical like anhydrous sodium silicate, but from the rice husk as. Inshallah, hopefully he can do it. He can give the better result, inshallah. And then F is more form for sodium silicate. There is like liquid, or it's called for commercial is water glass. So we have to use this one, the chemical, anhydrous sodium silicate and liquid sodium silicate. And then it's called alkali activator. So from the precursor is like fly ash, slag, silica fume, and fine sand is for the filler. We mix together the alkali activator, like number E and number F. And then the most expensive here is steel fiber, image of G. That is steel fiber, and it's come from the recycled steel. So steel manufacture and the process product, the product is steel fiber. That is like duri, apa ya, suban, very sharp, and how many times my hand become a victim from that one. This is so very sharp, steel fiber. And then the last is super plasticizer. Absolutely, my product is needed super plasticizer because my product is very drying, not like concrete like usual, because this is drying and need super plasticizer to increasing workability. Okay, next. Now HPGM makes optimization strategic. So for this experiment, we decide to make 3 variation. For the first is steel fiber variation. So we decide using 0 steel fiber for the control mix, and then 1 until 3% steel fiber for the variation steel fiber. And then the second is how to reduce anhydrous sodium silicate that we know there is very expensive one. So we reduce ASS or anhydrous sodium silicate, but increase the slag. Slag in, because the waste material so free. You can ask you can ask how many pun no problem, because free from the product, from the fabric. Fly ash free, silica fume free, slag free. But the expensive one is alkali activator, chemical substance. Okay, then the 3 is LSS replacement. So how we want to know the strength if ASS not using in this mix? So just using LSS for replacement. Okay, next. Okay, this is how the process begin to produce the HPGM. For the entire life, the process, there is mix around 6 process. For the first is raw material selection. So we have to careful how to find the good super fine particle for each the precursor. Precursor is fly ash, silica fume, and slag. That we know, fly ash is different. Even you have the fly ash from the one source, it looks like if burning first burning and then the second burning, is the result is different because they have a different temperature for the burn, and then the result is different also. So we have to control how the chemical content from the fly ash. If fly ash have a high aluminosilicate, if the aluminosilicate is not higher than we are expected, so we cannot use that the fly ash. So that's why we have to carefully to choose the precursor or raw materials. And then the second is alkali activator preparation. Before that, we mix the ESS or anhydrous sodium silicate and liquid sodium silicate, mix together the super plasticizer and water, letting it 1 hour. More than 1 hour is like what they call in English, yeah, but in Malay is lemau. More than 1 hour is not good. So there's maximum is 1 hour. less than 1 hour is also not good. So this is more carefully because the result is different. Okay, we letting for 1 hour and mix until solution, make a solution. Okay, 3 is mixing process. So at first we make in molen or a mixer for the small experiment. We use molen dry mix precursor and fine sand for the drying around 5 minutes mixer, and then gradually add the alkaline activator 5 minutes or so, and then mix for 5 minutes until achieving homogeneous consistency. And then after that, add super plasticizer and steel fiber, the last. And then after that, we have to casting and molding. That is depend on what your, like me, testing. I need to testing for compressive strength. It use STMC 39. There's using cube, the diameter 5 cm times 5 cm, and then we use for the beam like dimension is 10 cm and 5 cm for the flexural strength. Flexural strength I use ASTM C2993, and then after that we have to make cube and cylinder for durability testing. Durability testing, I use the STM C267. So for the three testing in here, I have to prepare cube, beam, and cylinder. Okay, and then 5 is curing process. The important thing for the make HPGM is curing process. For the first, if we want to make high ultra high strength, that is have to let in cold 2 days. Around 2 days in ambient temperature is around 26 something for the temperature, and then for the relative humidity is around 60 until 70 100 for the relative humidity. So we are control. And then the 3rd days there is using oven. After ambient temperature, we have to oven curing like 90 degrees Celsius. 90 degrees Celsius, we let it on the oven 2 days. After that, we, inshallah, we get the high strength, the HPGM. And then the final is testing. Testing is around about how you manage the time for observation. Okay, next please. Okay, now exceptional mechanical strength result after we are go to the testing process. For the first is we have the higher maximum compressive strength is 172.1 MPa megapascal, so very high. So this is if we compare to another concrete, it's like UHPG, ultra high performance concrete. We cannot compare for the normal concrete because normal concrete just until 50 MPa. So this is, we can compare to UHPC. And then RPC also, like reactive for the concrete. Okay. And then we have the flexural strength maximum is around 16.4 MPa. And that the decreased flexural improvement from the no steel fiber with the higher we use steel fiber 3%, there is around plus 102.5%. Okay, next. So there is make a proof that steel fiber is increasing the strength and enhance mechanical strength. And then now durability under aggressive condition. I make the durability test with use STMC 267 is immersion on the water, immersion on 5% H2SO4 or sulfate acid, or 5% in NaCl or salt. And then we get the result is In natural water exposure, all specimens retain over 95% of original strength after 90 days, with minimal mass loss less than 0.36%. And then in the 5% NaCl salt exposure, group 1, still fiber variation, that from the 0% until 3%, there is superior durability with negligible mass loss less than 0.13 and strength loss less than 5.6%, suitable for the icing salt region. So this is, it could be safe for the like beach, like salt region, something like that. Okay, then the last, before, okay. In 5% H2SO4 acid exposure, because we know we all in the Katulistiwa region, so we have the acid rain. That's why I make the testing in under acid, sulfate acid. Acid cause more severe degradation, but HPGM maintains structural integrity after 90 days, demonstrating higher resistance than conventional concrete. So if we compare the conventional concrete, HPGM is higher. Okay, next please. Now, this is just like we show the video, the last. This is how I design the concept of precast concrete block in road, embedded in the road, and then when the vehicle pass over the road in the well-paid zones, and then we get the vibration from that. The concrete, the HPGM, it's a cover, like precast, you see that the under. There is from the HPGM, and the inside is the spring. So if the vehicle pass the road, there is could be up and down and touching the piezoelectric system, and from that can be harvest the energy from the mechanical energy become to electrical energy. Okay, next. Now we are talking about piezoelectric energy harvesting system, because we have already the precast block concrete is already strength, right? And then now we go to the piezoelectric energy harvesting system. This is work from my college, Dr. Yonis. He is make piezoelectric energy in his lab, and then he proved that is can be take the some power for any loading that used for the sample. Okay, laboratory scale system was tested to convert footstep pressure into usable electrical energy. For the first sensor convert, I think this is not enough to clear for the figure. We go to the next slide. Okay, maybe I need to some notes from here, because we all know we are not civil. We are civil, we are not electrical, so we don't understand. But I'm trying hard to understand. Okay, for maybe I can explain. Block diagram for four-step power generation system using piezoelectric sensor technology. Now let's take a look at how the energy harvesting system actually works step by step. It all starts here. With the piezoelectric sensor, there is when pressure or vibration from footstep or vehicle movement is applied, the sensor convert mechanical energy into the electrical energy, producing an AC or alternating current. But AC current isn't stable for storage. So the next step is need bridge rectifier. Bridge rectifier is this component converts AC voltage from the sensor into the DC, direct current. The type of current needed to charge battery and power device. Next, the capacitor. Capacitor, the small amount of charge and smooth of the fluctuation in voltage, ensuring a steady power flow. And then the relay module act like a smart switch. It control when and how the store energy distribute. That is using the relay module. Then the DC power flows into the rechargeable battery. This is where all the harvest energy is stored, ready to be used whenever needed. From the battery, the energy can go through two different routes. If we need DC power, we can go like Arduino Uno. It is connected the monitor, voltage and current, helping us control and measure the system performance. So in summary, the system captures small mechanism vibration, converts them into the electrical energy, stabilize the output, and then store in a battery and makes ready for use. It's simple yet powerful demonstration of how everyday movement like footstep or vehicle movement become the electrical energy. So I think just like as long as we know there is wasting energy if we just look at the traffic or very crowded. It's unfortunately we cannot use this for the renewable source. Okay. Okay, next slide. Okay, now this is hardware setup of the footstep power generation system using piezoelectric sensor technology. Here we can see the actual hardware setup. For the first is shows here. The procedure produce electrical charge through the piezoelectric effect. That small electrical charge travels through a relay module, and the Arduino Uno. And then this device help monitor voltage, regulate flow, and control the power distribution. Beside it, we have an inverter, which convert DC power into the AC, allowing us to run standard electrical device. The generate energy is then stored in rechargeable battery. So there is store in there for the energy and ready for use whenever we can use the energy. Like the video before we show together how the footstep and make it the energy to make bulb light bulb and then the charger of the phone. And then next slide please. Okay, after the laboratory scale, we have a result from the piezoelectric system efficiency. For the no loads, we can get the 0.02 current for use 500 hours. Upon charging DC, 0.2 current for the 50 hours. For the light bulb AC, 1.80 current for 5.37 hours if we use the energy from the piezoelectric system. And then the combined loads, we have 2.08 current and then the result for around 4.81 hours. This is the result from the laboratory scale. Okay, next please. Okay, all of them there is very clear explain how the potential integration actually HPGM plus piezoelectric system. Now imagine how combining both innovation, the strength of HPGM with the energy harvesting ability of piezoelectric materials, the concrete protects the fragile sensor while the sensor convert vibration into the electric or the renewable energy. There is together they form a smart pavement that can carry heavy loads, reduce CO2 emission, and generate renewable energy all at once. Okay, next please. And the conclusion is for the future outlook also. In conclusion, HPGM shows remarkable strength and durability, and the piezoelectric system well for small-scale energy generation. Our next goal is to scale this up. How the product can be testing under the real application or the real traffic or the environmental condition, the real. This will require collaboration across material, electrical, civil engineering field. With continued research, we can turn ordinary roads into multifunctional self-powering infrastructure for the sustainable structure. Okay, for the last slide is thank you for your attention. I'd be happy to answer any question or discuss potential distribution in here together. We can build roads that don't just carry as a loading, but also make a power for the journey. Okay, thank you.
Leli Marini, give an applause for Ibu Leli Marini. The next session is for question and discussions for the for the participants. Is there any questions? For participant in Zoom, if you want to ask a questions, you can raise your hand.
Or meanwhile we waiting for the question, please the video, please open the video for our see together.
Mrs. Lely, Bu Lely, I would like to ask.
Okay.
Do you have any challenging in your research about this thing, and how you face it, the challenge, and what's the solution? That's my
Okay,
question.
thank you very much, Ibu Iren. Quite interesting question because if I can curhat in here, it's so many challenging from that start from the beginning in the lab, and from the beginning I know that what the point is from the supervisor need actually. So that is very challenging because my supervisor is from Hindi. Alhamdulillah, his English is very crowded or unpredictable. So actually it's many challenging from if I want to discuss in here from the how to manage the time. Actually I have to teaching also in here also, and how to manage the time for experiment, how to manage the time for the writing, and how manage the time for the making schedule on time. Actually for the material is not no need challenge at all because already provide on the lab everything. Alhamdulillah, I have the material, alhamdulillah, provide in there, And then for the equipment also, device also is already there. So anytime we can use that device. And then maybe like challenge, it's the timing. That is very hard to discipline for time. If we not have to discipline for what the target today, we can just wasting time. It looks like one day or a day is very important thing that you are a series researchers. You have to make something different. You have to give solution from the problem. So how you manage your interdisciplinary by yourself. So after that all, until here, I still learning. Okay, I think so.
Okay. Maybe from my colleagues, is there any question again?
Or we can start the video, please. So this is for the experimental in the laboratory scale, for the how the footstep, and then get the mechanical energy, and then change or convert to electrical energy through that device or the working setup. So this is the concept, how to footstep that the integration energy, and we embed it or integrate in the root. It's using the precast block concrete, something like this, and then the store in battery, and then the energy can be used for the street light. It's innovation. It's our goal. That's have many work after this to make sure this is can be used.
Bismillah. My name is Putri Yusela. I want to know that how does the variation in steel fiber content affect the increase in incompressive and flexural strength of HPGM, and what microscopic mechanism explain this increase? Thank you.
Okay, thank you. So, do you mean the steel fiber use? Steel fiber use depend on your budget. Actually, if you have many budget, you can use much of the steel fiber. It can be enhanced mechanical strength. But the problem is if we use more than, like I used to, my experimental, I used to more than 3% from the volume of concrete. That is like distribute for steel fiber is disturbing, not make a denser matrix compact. It's like not uniformly distribute, something like that. So the recommendation is less than 3% still of the weight concrete for using the steel fiber. And then for if we use 1% steel fiber also, we can get the ultra high strength. So why we use more? If we just use 1% is already get the what strength we need. Okay. It's enough.
Thank you, Miss.
Okay, thank you.
Okay, any other questions?
Miss Wiwi, please. One question.
Okay, thank you for having me. I want to ask a question to Ibu Leli, my lecturer. So, What are the optimal vibration parameters to achieve maximum performance without compromising material integrity? Thank you.
Okay, very nice question, I think, because we need how make sure our product is achieve a goal. There is we need ultra high strength, so we have to make sure my product is ultra high strength through the mechanical performance, and then through microstructural analysis we can use same EDS or FTIR. There is like a test microstructural that we get the sample the like 5 millimeter, and using that device and display in the computer, we can get the result like microstructural. We can get how the dense matrix, how the bonding of each other, the precursor, the binder, and the steel fiber also, and then we can get the chemical content from the alkali activator also. So we have to know the increase the ratio for chemical. We have to know how the influencing of the each of the precursor as well, and then we have to know that how the influence like environment can we get into the influence the effect also for the result. So we have to make sure this, and then alhamdulillah I have done all that tests for mechanical performance like elastic modulus elasticity also, and energy absorption capacity also, flexural strength and tensile strength for another my paper. So it could be concluded that my product is alhamdulillah ultra high strength. So I think I really confident enough for my product, for introduce my product actually. Okay.
Okay.
Okay,
Second
still
question.
any other questions?
Enough.
Second question,
Okay,
Miss.
Bapak.
Good afternoon.
Good afternoon.
My name is Alan from Polytechnic Negeri Ketapang. We are team, both of us. I would like to ask about this concept of research. Actually, very interesting because me and my supervisors in Taiwan also working on some kind of IoT device and build some robotics stuff. Have this research already considered about the comfortable of the driver or the human that walking through the pedestrians, something like that? How far the effectiveness of this concept if we try to apply it in a real case scenario? Thank you so much.
Okay, thank you. Okay, maybe I can say I can answer here. For the concept actually is already known. For the piezoelectric system, that is already known for in other country. Yes, there is look like footstep in the roadway, and then like Hindi using also in small road, but not heavy vehicle, just like vehicle that is can make the source of energy for the street light. Yes, I think that the concept is already known. And for the maybe like vehicle, heavy vehicle, it's the new thing, because I never get the article talking about that, the how we can use this system in under heavy vehicle or the crowded traffic, something like that. what else?
Have this concept already considered about the comfortability of the driver or the car passing through, or the humans that passing through the pedestrians?
Yes,
about the
already.
comfort already.
Yes, already.
Is
Many
that,
country.
is that acceptable? I mean, is there any kind of evaluations?
Yeah, they like feel like enjoy through the system, and then can get like already. It's like we can touch this, and then the leg is bulk, something like that. So there is enjoying actually. Many country, and I saw in YouTube, they are using that concept.
Thank you so much.
Yeah, thank you.
Okay, is there any questions? Maybe it is the last questions for Ibu Lely Marini. Giving a pause for Ibu Lely Marini for the presentations today.
Thank you.
Thank you, Ibu. Okay, for our last speakers, Ms. Mahmuda, can you hear me?
Yeah, I can hear you.
Okay, could we start now?
Yeah, that's fine. Can I share my screen?
Okay, but before we start, may I tell about the brief of your curriculum vitae first?
Sure.
Okay. Our fifth speaker is Ms. Mahmuda Khanturi, MSc. Ms. Mahmuda is now a project manager for Masjid Nur project, and she is a lecturer in City of Glasgow College for subjects including constructions management, fluid mechanics, materials, designs of building structures, design of structures, and detailing. Today, she will be presenting on the topic retrofit and modern methods of constructions. Please join me in giving a very warm welcome to Ms. Mahmuda Khanturi.
Thank you. So I'm just going to share my slides, and so I can start. Can you see the slides?
Yes.
Great, thank you. So today I'll be talking about modern methods of construction and retrofit in the built environment. In the UK, we're going through a lot of challenges in terms of the built environment, predominantly with how do we build it more efficiently, in a more sustainable way, but also in a way that is more resilient to the changing climate and changing kind of temperature demands that we're seeing in the UK. In particular, we're seeing warmer summers, wetter winters, areas which we're getting flooding, which we've never got before. So these challenges are really big challenges for the country and for the built environment. So as part of today's lecture, I'm going to just quickly go through what is modern methods of construction. In terms of technology, modern methods of construction has been in the UK and in Europe since the Second World War. But I think in recent times, with changes in technology and better methods of understanding how we can build, modern methods of construction have really taken off as a form of construction that, to be honest, most projects will look at to save money and be more efficient. So what's modern methods of construction? Why are we using them? Modern methods of constructions are approaches that streamline the construction process. So what we're trying to do is become more efficient, improve the quality of what we're constructing, but also give the customer a better product. Most modern method construction built projects you take into account sustainability. So, you know, the sustainability in terms of the materials that's being used, how much material is being used, how much is being wasted, and then delivery. Most modern method construction approaches will be able to deliver projects very quickly because of just the efficiency of using the method of modern method construction. There has been a lot of success in UK and Europe using these forms of construction. I will be highlighting a few examples of projects where modern method construction is being used, and the types of modern method construction that are currently being used in industry. So modern method construction is predominantly prefabricating. Now, prefabricating means fabrication that's usually not on site, usually whether it be in a factory or off-site. This is really fundamental to the modern method construction process. And then bringing the items onto site once they are semi-built or built. This kind of off-site method of fabricating really enhances efficiency and reduces waste, improves safety on site as well. In the UK, there's been really a move to improving safety on site to reduce the number of injuries we get on site. And one of the ways we have been doing that is by using modern method construction, by not trying to reduce the amount of work we do on site, how complicated the work is on site and things like that. Really trying to kind of streamline how we work. So just some of the terminologies for you to understand. I've already explained what modern method construction are. Pre-manufacture, so we want to reduce the level of labor on site. You know, delivery risk, this is a really big one for anyone who works in construction. How do we ensure that we're building to the time frame that we say we're going to build? And modern method construction really gives the control back to the contractor, really gives the control back to the contractor, who can, if by using modern method construction, try and reduce risk of delays on site. For example, if the weather isn't great, you can still manufacture in a factory, for example. You can reduce the amount of labor if you're shortage of labor, and this is a problem in the UK where we don't have as much labor available or labor that's trained, and therefore it can be difficult for projects in certain locations to be delivered. So how do we manage that? And modern method constructions, again, is a way that's helping to manage labor shortages. Improve productivity, I've already mentioned this. Improve how we manufacture, the use of robotics in the factories, the use of an environment that is predictable and repetitive. These processes in modern method construction are repetitive, which is really important to get an end product that's of high quality. And this is where modern method construction is different from what it was 60 years ago, is that we're producing a very high quality product. Off-site construction, already mentioned this, you know, 40% of construction is built on site. We're trying to really reduce this. And by applying modern method construction, we can reduce this even further. Go to the next time. So when we're talking about modern method construction, there are four kind of main types that we talk about in the UK and we really focus on. Here are the four. You've got panelized systems, volumetric systems, sub-assemblies and components, and hybrid systems. Now, all four are used, and they're used at different scales, okay? So I'm not just talking about small housing projects. You can talk about commercial buildings, you can talk about, big skyscrapers, towers, housing, offices. There's an array. In the college building that I teach at, they've used a lot of different types of modern methods of construction to create a college building. So another kind of benefit of modern method construction is that you can apply it to lots of different kind of buildings within the built environment. And it's not just for housing. A lot of hotels in the UK are using this because it's a quick way of building. A lot of developers like it as well because they can reduce their risk of delivery and ensure they can deliver on time, which obviously developers love. So I want to quickly go through panelized systems and what these kind of different systems are. All of these systems use a variation of these four materials. So modern method construction is not for one type of material. We can use concrete, steel, timber. We can use sustainable materials. We can use lots of different types. And I'm going to kind of touch on that as I go along. So again, the use of different materials is something that is becoming more and more common within the industry. Buildings are no longer just concrete or just steel. They are a combination of different materials. Again, the drive for this is sustainability. We're not sticking to one material when we're building. We are trying to use each material in the most efficient way within the building. So a lot of the time, we'll be using concrete and steel together in a building, or timber and steel, as a kind of hybrid, which is again one of the kind of trademarks of modern method of construction. So what I want to do is go through the four types of modern method of construction. Just going to keep this down. So the first one is panelized systems. So these are generally flat systems. If you think of a wall or a roof, usually built in a factory off-site and then transported onto site on the back of a truck, and then they form part of the structure. Sometimes they can have a structural function and be like a structural wall or etc. Or they could just be aesthetic function only. So different types of systems in panelized systems. You've got open, usually with no insulation, just the structure itself on one side. We can have closed systems where we put the insulation in, everything's ready, we can clad it, we can put doors, windows, we can run some electrical wiring through it and then bring it onto site, which is becoming more and more common actually, that we're trying to really maximize efficiency. So imagine if you've got a panelized system, just to show you what a panelized system looks like. This is an open panel system where you just have kind of like a timber kind of wall. You just have your membrane, you've got an opening for your window, very cost efficient, it's quite lightweight, you can put it on the back of a lorry, you can add whatever finishes that you want to it, and you're really set to go. While a closed system looks something like this, where you've added everything. So you've got your timber frame, you've got your insulation, and in the UK we have cold weather, so insulation is very important. How do we retain heat within our buildings? How do we ensure that heat isn't escaping? And by having all these layers put together in the factory, what we're saying is that we're reducing kind of that inefficiency of things going wrong on site. Everything is done like to the millimeter, you know. The accuracy within a factory is really high. There's a high checking process and things like that. So this closed panel system show you that you're putting all the layers of the kind of the building material in, including the windows. You can even put cladding on the front. So when you bring that piece onto site, it's ready to just slide in. And the contractor just has to put it in place, and that is it. They don't need to do anything else. Just lift it in once it's on site. I just want to show you this. This is an example of a panel makeup. It's a structurally insulated panel. This is a very sustainable material. Okay, what you can see on the image is that you have kind of like a timber board. Okay, this board is from recycled timber. Okay, it's very cheap to make and use. It's very lightweight. It has high strength. It doesn't need to be very thick. Okay, and within the timber is insulation. Okay, which is like a plastic insulation that's glued in between your timber panels. And this is a form of a modern method of construction wall, okay? And we use this for housing projects and things like that to form part of the wall. It's very quick and efficient form to use for house building in particular. And just an example of how we kind of fit that into a large panel. You can get 3 panels, SIP panels here together. You clip them in, you have a joint, and they literally slide in together on site, and nail jointed in, and you can very quickly start building. Now, the key thing for things like this in terms of modern method construction is that when you're on site, you don't need someone who's very highly skilled. For anyone who is aware, in the UK, we're struggling with joinery skills, people who know how to work with timber and has a very high level of skill to do that. When we're talking about modern method construction, we're taking the level of skill completely down, and we're saying, hold on, we're going to give you the parts, you just put them together on site. It's just a simple nail and you put it in, and it really makes the process much more simple and easy. Example what that looks like on site here. They're building a house with 6 panels. You can see there's 3 people here, 1 person holding the board. It doesn't weigh very much. It's not heavy. It's not dangerous. Okay, these are all very important when we're talking about being on site. And they're literally gluing it in, the panels next to each other, just glue gunning it in to form a home. Now, volumetric and modular systems. These are more 3-dimensional systems. Again, they're used in projects currently. Recently, a hotel in Glasgow used volumetric systems. Hotel companies really like this form of modern method construction. It's very efficient, very quick in terms of buildability point of view. Here is an example of volumetric construction for a hotel in the UK. You can see these pods are identical. Firstly, they are lifted in on site by 1 crane. Okay, they come into site fully built, and I'm going to go through. I don't have further slides. They are fully built, so inside you have everything in the electricity done. Sometimes for the bathroom, they'll install the bathroom, they'll paint it. Everything is ready to go. All they have to do is just place it in on site and attach it. Once that's done, it's built. Volumetric constructions, really common. And all of the whole kind of pod is built on site, and it comes on the back of a lorry. And once it's on site, it just has to be lifted, and then it's good to go. Hybrid systems. Okay, so this is where you're kind of merging combinations. So you can have here as an example, which again we do a lot in the UK, is where you have panel systems and combine that with a volumetric system to create a bathroom pod for a hotel, for example, or a housing development or hospital. This is kind of combining traditional form of construction with modern methods. And again, this is something that we do as well. You know, traditional kind of concrete systems with modern methods of construction, panelized systems, is something that we try and combine to make the structure as efficient as possible. Now, not all the time we can do volumetric construction, and when it's difficult and when we have larger structures or more complex structures, we try to rationalize the structure. We try to create sub-assemblies where, you know, the main elements we can try and manufacture in a kind of separate way. Examples, for example, trusses on a roof. We try and construct that and bring that onto site. Already manufactured, so that once it's on site, they just have to put it together. Examples of sub-assemblies, precast staircases. Usually that will come on site constructed on the back of a lorry, and we just place that in. You can see there here, this is a roof truss for the roof. These are sub-assemblies built in the factory, and we'll just bring them on again on the back of a lorry and onto site. Examples of kind of things that we can do. Here is an example of timber beams, again pre-made in the factory and brought onto site. What we're trying to do again is trying to optimize structures, we're trying to optimize design. How can we use the most efficient amount of material in the most efficient way, with the least amount of material, to give us what we want in terms of the built environment? And it's really about optimizing structures. So most of what I've been saying has been off-site methods, where we'll be saying most of the structure is built off-site and it's brought onto site and put together. There are also forms where on-site we are trying to use modern methods of constructions, and these include tunnel form, thin joint blockwork, and insulated concrete formwork. Now, I just want to quickly run through some of this tunnel formwork. So this is where the contractor will cast the walls and slabs in one operation in a daily cycle. So again, recognizing actually, if we try to mirror what we do off-site, on-site, can we be more efficient? Can we improve our speed, quality, and accuracy, as we do in modern methods of construction? Another example here is using insulated concrete formwork. This again, reducing your time that you're spending on site, putting up formwork and things like that. These kind of insulated panel provide insulation, tie your steel together, and they remain in place. You're not moving them, okay? They form part of your final structure. And for anyone who's worked in concrete buildings, formwork can become a really big part of your kind of construction process and cause delays and things like that. So it's one process that you're not having to do, remove formwork, add formwork, and it's there as a permanent part of your structure. Okay, so that's kind of me covering modern methods of construction. The second part of what I want to talk to you about was retrofit. Now, retrofit is emerging in the UK as really something the government is trying to promote. For those of you who know, the net zero targets for 2050 is something that the UK government is really trying to pursue. And what we found is that we are losing a lot of energy in our housing. We're not very efficient in our housing, and that's costing us a lot of money, not only in terms of energy cost, but also in terms of sustainability. We're not very sustainable. And the image here is just showing you where we're losing a lot of efficiency in our housing. So we're losing heat through our windows. We're not ventilating properly. Heat is being lost, and we're just using more energy to heat our homes than we actually need to. And the reason for that, just for you to understand the context, is that much of the housing in the UK was built post Second World War, and a lot of the housing hasn't been invested in, and since the Ukraine war, the rise in energy costs has really fueled people's desire and understanding that actually we need to be more efficient with the energy that we have. We need to be more sustainable. We need to think about the future of our housing, and also how do we provide the energy that we need to heat our homes. So just to kind of give you a background of that, the built environment accounts for 25% of UK's emissions, okay? So this is a big chunk of our emissions, and we're really trying to reduce that number down. And retrofit is a way of doing that. A retrofit is a way we are trying to reduce that number. Now, this diagram here is showing you where we are in the current state. So a UK average residential home, the CO2 that we emit from our homes, 60% is from heating it. 60% of our CO2 emissions from our home is from heating. Most homes have gas boilers or electric boilers to heat their home. So it's a big chunk of where we're emitting CO2. The other big chunk is our appliances, okay? What types of appliances and lighting that we're using, and hot water. Now, if we retrofit our homes, if we improve the windows, the insulation, we improve how we retain heat in the structure, what the diagram on the right says, actually, we can have an 80% reduction in the CO2 that someone in an average home in the UK can produce. 80% reduction is a really large amount, and that's just by retrofitting. Now, what is retrofit? Retrofit is where we're improving the insulation in the home. So we're trying to think, how do we keep the heat in? What can we do to keep more of the heat in and let less escape? We can add insulation. There are different types and ways we can do that. We can improve the types of windows we have. Now, this is a really big one, and to be honest, as I've been learning about this, that the amount of energy or heat that we lose from our windows is really huge, and this is really something that the government here and the building environment is really tackling now. Ventilation, how do we make our homes adaptable? So in the winter we want them to be warm, but in the summer we want it to be cooler. How do we do that? What can we do to allow our homes to kind of breathe? And this is really something, again, that we're learning to do, and we're trying to adapt to as we get hotter summers and cooler winters. How do we allow those kind of different temperatures to occur within our home, and ensure that we have a good quality of environment? Air tightness. How do we ensure that air's not coming in and going out of homes? And this is a really big problem with older housing. They're not very great at keeping air in. Thermal bridges, again, heat being lost through different forms. If you've got a balcony, heat being lost through your balcony and things like that. Moisture. We have a problem where if our ventilation is poor, we get moisture within our homes. How do we prevent that? How do we make our homes better at not absorbing moisture? And again, this is a really kind of big challenge in the UK. If we retrofit, and this diagram again is showing, if we can retrofit our homes, we can significantly reduce the amount of energy that we need. So a home, a detached house in the UK, we can go from 667 kilowatt hours to 55, which is a really kind of significant reduction, over a two-third reduction in terms of the amount of energy we need. So retrofit is really something that's going to help us achieve our net zero targets. Now, just some of the technology that's helping us retrofit, and I just listed them here just as a kind of point of reference. We have BIM, which I hope most of you have heard, where, producing models of our environment in terms of a BIM environment is really something that's beneficial in terms of coordinating design, but also making sure that we are designing really well. We are starting to do 3D scanning, LIDR technology in retrofit. So if we scan the environment, and then we can show clients, oh, we can change this, and this is how your home will be changed, and things like that. Or augmented reality and virtual reality. A lot of this is being used in the built environment to get people to understand this is how we're going to change things, this is how it's going to look. So that they can fully understand what we're actually trying to do with retrofit. Smart building solutions. Now, this again is emerging. So, like when you're in your home, you can control the temperature in your home. You can control and ensure that the temperature stays at one set temperature. It doesn't go up and down. Again, this is about efficiency. A lot of the time in infrastructure, we've talked about putting and making smart infrastructure. Smart housing is also important. Can we have windows that are automatic, that allow air in and out to ensure that there's ventilation? Can we have moisture? Can we monitor moisture in your home? And these are kind of the things that we're trying to kind of inculcate into our housing. Advanced materials and sustainable solutions. There are numerous forms of advanced materials, whether they be insulation, damp proofing, waterproofing, really emerging within the retrofit to make our homes better homes. And the last one, monitoring performance, understanding, and we are better now at looking where are we losing heat. We can detect what's happening, we can visually see it, and it's really changing the way we are adapting our homes to allow us to retrofit. So I think that's my last slide there. Thank you very much everyone for listening. I hope it was informative and interesting. Thank you.
Okay, thank you, Ms. Mahmuda, for your presentations. Next, we move to questions and discussions. For the participants, is there any question? Okay, Ibu Putri.
Okay, Chick. Okay, thank you. My name is Putri. I am new lecturer of Civil Engineering Department, State Polytechnic of Pontianak. I want to know about how can panelist system improve construction efficiency and quality, and how to make sure the quality and safety of the panels. Thank you.
Okay. So one of the biggest things about panel construction, obviously, is that you're bringing the panels onto site as set pieces which have been kind of built to the size that you want. So once they are on site, it's more about the joint connection. So ensuring that the connections between the panels is constructed correctly, and this is where we have become much better at designing connections, which is where the integrity of the structure is. So, for example, high levels of adhesive or connection joints, all of which allow this to be a more efficient form of construction. And this is also about site safety. If you think about trying to build the panel on site, to actually, I'm going to get a delivery today, I'm going to get 10 panels, it's going to come on the back of a lorry, I have to lift it in, and I have to just make sure I have 4 or 5 people who know what to do and can connect the panels on site. That can be done very quickly, you know. In terms of efficiency, you're talking about less than a day's worth of work on site. So you're taking the kind of emphasis off the contractor on site, and putting it back into a factory, and again, that's reducing risk. It's about uncertainty and taking away some of the uncertainty in the construction process. I hope that answers the question, Putri.
Okay, thank you, Ms. Mahbuda, for the next questions. Tell about your name and then your affiliation.
Hello, my name is Diwani. What are the common challenges faced in implementing penalized system and how to overcome them? Thank you.
I think one of the biggest challenges, and again, I think it's a challenge where whatever built environment you're in, is that it's a new technology. How do you convince a client that this is going to be a better solution for them? Yeah, and a lot of the time, clients, because they've not experienced it, they are very reluctant, and it is about having confidence, and this is where the work that that we do at the college, where we're promoting or getting our students to learn about these forms, is about getting the kind of the knowledge out there. So I think that's one of the challenges, is that clients, it's about risk again. Clients, they're like, oh, we've used concrete, we've used steel, we've not used modern methods of construction. Am I taking a risk? Do I know enough? And it is about a knowledge share. And it's about knowledge, like how people understand, how you can get people to understand. And that's a role that not only engineers but architects are taking on now, where we have a role in terms of our role of implementing sustainability, where we have to tell the clients, actually, there's a better, more sustainable solution, which we should recommend to you, and we think is a better solution for you to get what you want. And this is what we do. We go through the processes with the client to show them that these are the different options that you have, and try and get them to understand that. I think that's one of the biggest challenges. But in terms of material, it's not a challenge. You use recycled material for much of these products. So the challenge isn't in terms of material, it's just getting people to understand, actually, this product is a high quality product. It might look light and it might not look as strong as concrete, but actually, if we build it in a certain way, we can produce the same or better results. And it is a knowledge of the products. Thank you.
Thank you, Ms. Mahbuda. For the next questions, okay. Mention your name first. stand up, please.
Hello, my name is Riwahini Rafika. My question: when modern construction technology meet historic architecture, how can we answer the innovation becomes a dialogue between generations rather than a repetition of identity? Thank you.
So, I mean, implementation, I think a lot of the time what happens is that new technology, to some extent, has to be supported by governments to be allowed to become something that's common and shared knowledge. And a lot of the time, it is the government who are spearheading forms of technology through policy. At the end of the day, policy. So net zero being one of the policies where actually the government has a target for the country. How does the built environment play a role within that? And then how do we do things differently to help allow us to meet those targets? How do we become more sustainable? How do we use materials more efficiently? How do we make concrete more sustainable? Or how do we use recycled steel? These are all things that we are asking the questions now. There are projects being built now that 10 years ago, 15 years ago, wouldn't have been built the way it's been built. So this push from policy is really important for us to push in technology as well. The investment that the government has and puts in is really fundamental to where the commercial sector is going to move. And it is a play on that the commercial sector within the built environment will move where the policy sits fundamentally. Thank you.
Is it clear?
Okay, thank you.
Okay, any other questions? Okay, one more question. Please stand up and mention your name first.
Hello, my name is Salva. I want to ask, could digital twins and immersive simulation allow engineers to resurrect existing structure virtually before any physical retrofit, essentially testing the future of the past?
Okay, thank you. So, testing retrofit, from what I understand, that's what you're saying. There are methods of checking how much heat you're losing in your home. So we can have these heat sensors that can measure how much, where your heat loss is within your home, and then identify, okay, here are the areas where you're losing your heat in your home, and then work from there. So for example, if you do like a heat check on your home, it's like a heat sensor. It says, okay, you're losing this much heat from your windows, change your windows to double glazed windows. You are losing heat from the roof of your house, so you need to insulate your home. And so that's a kind of one way of kind of identifying where the heat loss is in terms of occurring. But also, what we have to understand is a lot of the time this new technology emerges, and it's about, like I said before, getting people to understand why they need to adopt this technology. Why should I spend so much money on my home to make it more sustainable? Like, you have to explain the benefits, but also, and that's where kind of virtual imagery, giving them examples, prototypes come in, where people can understand and then adopt. A lot of the time people don't want to adopt new technologies, and a lot of the time things like retrofit will cost people money, which maybe they're not willing to spend on their home, and that's really kind of the challenge, is that when you have a country where you have about 60 million people, how do you get 60 million people to invest in their home to make it retrofit? You know, how do you convince people actually it's worth the investment? Or how do you promote that? And these are the challenges. It's not just a technological challenge, it's a societal challenge where actually our built environment has to change, because we are needing to meet these targets. We need to be more sustainable, we need to be more resilient. And how do we achieve that? And getting people to become more and more aware of those challenges is becoming much more of a need than ever before.
Okay, thank you, Ms. Mahmuda. Any other questions? No? Okay. Okay, thank you again for Ms. Mahmuda for sharing your valuable expertise. Giving applause for Ms. Mahmuda.
Thank you.
Ladies and gentlemen, we have come to the close of our sessions on international conference today. I would like to extend a tremendous thank you to all of the brilliant speakers, for Bapak Wisena, Professor Ling Jianhua, Professor Kwok King Kwok, Ibu Leli Marini, and Ms. Mahmuda, for their outstanding presentations and for enriching our understanding for the crucial topic. On behalf of the conference committee and all the attendants, thank you for your active participations and thoughtful questions. This session is now concluded. Thank you and enjoy the rest of the conference. Wassalamualaikum warahmatullahi wabarakatuh.